Hello and good morning, everyone. My name is Sebastian. I'm the Novice Prospect, and we're doing some game development today. Now, there's a bit of a plan here. I want to basically go starting off making a game just in code, okay? Well, we're going to do this in C#, and we're going to use something called MonoGame. It's essentially a reimagining of what was called the Microsoft XNA framework. Basically now we are able to do graphical things in C# without needing to rely on like DirectX or like extra libraries to do things. Now, the plan here is we're going to do a tutorial here in MonoGame, and then we're going to pivot. We're going to go and do sort of a similar thing, run the tutorial for Godot. Now, I chose to run the Godot Mono version just because I like C# and I'm really familiar with it, which will mean we will need to do things slightly different from the tutorial, but you know, it's a learning experience. And ultimately, then the plan after that is once we've made the game in Godot, the tutorial, maybe we'll do an asset flip of that same game and we'll just make our own version, come up with our own graphics and what have you not. This is all sort of learning now the intricacies of not just programming, but game development. And I have no clue if I'm going to be able to pull this off, but we have a tutorial, and this is going to build what's called Dungeon Slime. It's essentially a snake-like game at the end of it, and we will basically just go through the chapters here and get started. So, nothing much here of interest to us. I have installed already the requirements for Mono, for the MonoGame library, all that, the project templates is all installed. But you can literally just follow the steps here, depending on your platform. Install all the extensions for C# for VS Code if you wanted, and I would absolutely recommend that because it really helps you make basically deal with the assets, because there's an extension for that, and you know you actually get code completion for that specific thing here. We also have set up Wine for the effect compilation, which means normally on Windows it would just run this through DirectX, but on Linux we basically have to run that same sort of setup through Wine, which again, Wine is not an emulator, it's a recursive acronym. Basically, when it needs to do any shader compilation, it does so through Windows, through an extra Windows layer. But what we're going to do is we're literally going to go and create a new project in VS Code. And if you want to, docsmonogame.net. I will make sure, obviously, to link this in our future project or repo. But yeah, basically, I will put this on the other screen so I have a little bit more space here. And let's go into repos, and then we're gonna it's a new project in a directory. Why don't we go and make learning mono game? Okay, I will copy one script. Oh, not LMG, LMG, not LGM. Make. Do we not have a make file in there? And hi, Ronnie, nice to see you. Sorry, I completely forgot to say hello. I get sidetracked easily, which does remind me. Let me go and do a thing. If this works. Oh, but not. Swear to God, me and typing today is already.
I guess they're getting shoutouts.
I know.
You have no idea who they are.
No, my keyboard is not listening to what I want to be doing. It's fine, it's fine. Can we do this properly, please? It's fine. Later, I will do it again.
It's fine.
Let me go and actually check out the directory quickly. I thought I had a make file. Oh. We need to go one back and then lm this. Yeah. LMG / and then I should have a make file in here, and we're going to copy it straight into ours. Let's open Visual Studio Code here. And more space. So we are now in here. Let's go and quickly look at this make file. This make file is essentially a better iteration of the one that we used in our C# calculator project. I've basically generated, made it a bit more generic, and also made sure that when we make Doxygen Doxygen documentation, that we are also able to we have servdocs right down here as an extra makefile path, and we can basically say, hey, okay, we've generated the documentation, now show me it locally, and we can confirm it's actually the way we want it to. I have the Windows build already built in here, so we can basically say make Win or just make, and then it builds for Linux or Windows depending on how we do this. So that's the start of it. We probably want, bless you, we want to make a new C# project. So new project. Right, now it's going to discover the project templates that we have installed, which hopefully I should be able, MonoGame cross-platform desktop. So MonoGame cross, there it is. Name the new project, and we shall call it Learning MonoGame. And you will make this right in here as an SLL solution X and do it. Well, I suppose this will work. No, I don't think I want this. 2 seconds. I am realizing it's fine. We can fix. Although no. Let me check quickly what I've done here. So the app name. So no, this is actually fine. Because we will create a library as well, which will live in the same directory. Okay, cool. So we're so far so good. We've done all that, and essentially, well, the interesting part is we essentially already have a running game. Well, not a running game, but a running game window. So this is a C# debugger, and launch the startup project, which is Learning MonoGame. So hopefully we will have a launch JSON later on, but building, running, and we have a blue window. Like, this is literally our first, we have a game window, and if I wanted to change something about this, for example, we could say, hey, I don't like this blue color, let's find some sort of dark gray, slate gray maybe? Dark slate gray, that sounds cool. Let's see if that change comes into being. And boom, we now have a dark gray background window, right? It's a simple start, but we have a game window. Now, let's...
Nothing.
Um,
Looks green.
Really?
To me, it looks green.
Well, it's called dark slate gray.
In the computer spot then. It may be grey, but it just looks green to me.
Okay. Well, I don't know about colors, but we'll just go with this. But let's actually quickly walk through the existing code so far, right? I think this is sort of really important that we understand, how did this window come to be in the first place? And this is actually not all that difficult. Let me go and make this a bit bigger. I'll move you somewhere else. Actually, let me make you floaty and smaller, and then I can move you somewhere. Right, let's walk through this. So we have a class called Game1, and like maybe we should start right there and say, hey, I don't want this to be called Game1. We'll call this actually, we will call this Dodge the Dudes. The game's actually called Dodge the Creeps, but you know, I found Dodge the Dudes better. And now, interesting enough, it hasn't renamed the file because realistically you can name the file whatever you want and the class can be named whatever you want, but it's sort of been established that what you want to do is, if you have a class called Dodge the Dudes and you want the name of the file to be the same as the class. And like I can literally say here, hey, we have a rename action here because, you know, he's realizing, hey, we're not really following the standards here. Anyways, that is in itself derived from a game class, and we can probably actually do a search into this because this is literally from the XNA framework, MonoGame. Right? Whenever you see XNA framework, think MonoGame, but they just done a wrapper around it, okay? But it's still underneath all this Microsoft XNA framework. But basically, we just have a game class. It's a disposable class, which means once you clear the window, you know, it automatically goes and frees all the resources. And there's a whole bunch of functions in here that we don't actually really care about. It's just to know, okay, we are deriving this from some sort of base class. And then you make what's called a graphics device manager. Let me turn the music down just a wee bit. Which basically gives us a context to a graphics device, you know, the actual graphics card, but it's a sort of it's a theoretical version of a graphics card because the software itself isn't aware of whether we have NVIDIA or AMD. It doesn't really care. It just knows, hey, I need something graphic, operating system, give me that context. So then we make what's called a sprite batch. And a sprite batch is essentially just a collection of images that we can then, we then, in the actual construction of the class, we say, hey, we make this new graphics device manager as a context. We basically say, hey, where does the content live, right? As assets, pictures, music, all that lives in the /content directory. And is mouse visible true? Like you can literally just set options like that, and then you basically have an initializer which calls into the base class. So again, we are, you know, deriving all this from game, and that means we need to go and call these base functions while we can also do our own initialization. We can do our own loading of content, and then it comes what's called the update function. Now the update function is something that runs every frame. Okay, every frame. You do something. You move icons, you look at button inputs and you react to those button inputs. But all this happens in this update loop. Okay? And then you have a draw loop, which basically takes all the prepared content that we have made in our update. We basically said, okay, the next scene or the next frame has to have these changes in it. Okay, this is where you then say, okay, we've pushed to the right, for example, and we now make our character move this many pixels, move to the right. And that happens, the actual drawing happens, as you can imagine, in the draw call. This is where we then say, okay, we have this graphics device. First off, we clear the current frame, so we're not overlaying, you know, multiple frames on top of each other. We're making a new frame every time. Then we make some drawing code. We don't have much yet because we have nothing to draw. And then you say base draw. This is basically calling back into this base class from game. And we take in a game time. Now, I'm not entirely sure whether this is a total time, as like a accumulated game time, or whether this is a delta time. I'm not entirely sure how that is being done. Can we find out? So in the next chapter, chapter 3, okay, this is actually now sort of walking us through this code. Yeah, update and draw methods, graphics and rendering, initialization. This is exactly what I would expect here. Then in the game loop, we do all this. Oh yeah, for example, this is actually a cool bit of tidbit of knowledge. We've just spoke about the clearing of frames. Well, the old Microsoft Solitaire, when it did the card draw, it didn't do the clear. It just kept drawing cards over the frame. This is how you end up with this effect of these falling cards all nicely aligned, as you can see on screen. And this is literally just a trick of saying, hey, we're not going to clear that previous frame, we're going to keep it and just draw more on top. So that's literally how they made that back then. They just decided, hey, well, we're just going to leave it there and draw over it. Right, it's such a simple effect.
Yeah.
If you think about it, right?
That's how I know that I got good at it.
That's true. That is true indeed. And in here they're actually saying, hey, go and change it to a different color, you know, and then maybe you can make that happen. the game time. The game time parameter provides a snapshot of the timing values for the game, including the amount of time that it took for the previous frame to execute. This is exactly what I was wondering, right? So this is actually delta time. Now, when I say delta time, for those that don't understand that particular phrasing, it just means the difference between previous time frame and now. So if you were to say, hey, I'm measuring time right now and now, then that is a delta of 2 seconds. Hey, Smetnol, how's it going? Welcome in, my friend. If we are doing game development, we are learning MonoGame, and then we're going to pivot over to Godot, and then we're going to make our own game. This is going to be over the next couple of streams. This is not all going to happen today. I think we will be too busy with just the one game engine today to get somewhere, because I'm also trying to obviously explain how we're doing things. But yes, so the important part for me to understand was that in this game code, or in this code here, game time is actually a delta time, meaning it is the difference between the previous frame and the current frame in terms of like how many milliseconds or seconds have passed between those. That is actually the delta time. You're not getting back this frame was generated at what's the time right now? It wasn't generated at 8:30 and 25 seconds. No, you actually get back this difference on that makes it actually easier. I don't know about that, Geckos. Welcome in. It's a lot. We have a lot to cover. It took me 3 streams to make a calculator work. So, you know, I am not a programmer. I'm a tech support guy. I'm learning. We don't need Docker, by the way. But yeah, so we have a basic game class, and we can then say, hey, let's go and create a library, because you want to end up in a situation where if you have something that you use all the time, you make a library, and because then you can take that library and port it into your next project and just work it again. You're not reinventing the wheel every single time. So I like the fact actually that a lot of tutorials, I'm going to be honest, what they do is they have you dump all the code into like one class and say, okay, here's your finished thing, and off you go, right? And do the rest yourself. MonoGame is sitting here literally in this tutorial, and they're actually teaching you and helping you create your own game engine library that you can then just import over and over again, but because it was you actually making it, you understand it better. I love it. Yes, most of the time. But no, in my last job, I was actually doing like network designs. I was doing a lot of debugging as well. So like in my case, I was mostly just reading logs, understanding what was happening, then talking to the devs and saying, hey, you know, this is what I'm seeing here. So I've had contact with development in that. Yeah, I've had contact with developers and that whole way of living and thinking. I'm just not someone that's ever earned money with this or ever made a project, finished a project to completion or anything like that. But yeah, that's sort of why I'm doing all this. I want to get better. I want to understand things more. So first off, we need to make a library, and then we need to add that library as a reference. So fairly straightforward. First, we say we want to make a new project again. We search for MonoGame, and there's a game library. That's what we want. And we'll call this the Novice Game Library, right? I don't know. That will be created in there, yes. So here's our game library. Fantastic. And then where's the actual? Yeah, that's you. No, here you. Okay, can we add project reference? Yes. Select the project to add the reference to. That is the learning MonoGame, and the project to reference is the game library. Cool. And we can actually confirm that that has happened. We can, is this part of the solution, or no, it's normally in the project. We should see yes. In the project here, we see this include saying, hey, go one directory back, go into Novice Game Library and get that project as our reference. Sweet. back and works, back and forth. Yeah, it's all good, man. Take your time, and you know, work comes first, of course. Real life always comes first. um, but you know, we've now done the preparation for our next step. So we've added the reference, and it's actually telling us there's a whole bunch of stuff in that we don't need. So let's open the game library, and indeed, I don't need the config directory. We don't need the content folder because we won't have assets in the library. That makes sense. And we won't need game CS because we will make our own new classes from that. So that's literally what's saying here. All right. So even explains to you why you would need these files. Each targeting different platforms. Okay. Cool. And then you have actually the 2D starter kit and 2D blank start kit. They give you sort of a bigger setup in terms of doing cross-platform compilation. But we don't need any of that right now. We're actually going to just follow along here. And this is where we actually now create our first code. I feel like copy pasting is going to just be the lazy option without us actually understanding what we're pasting in. Okay, so you will see me actually typing all this out. The only thing I will probably copy is like big common blocks. Like something like this, I will just go in and then copy that entire common block. Smaller ones we can just probably copy ourselves. Like I don't mind doing that typing, and again, I feel like if I actually type out myself, I have more of an understanding how these pieces all fit together, rather than just copy pasting and say, hey, I've got code. Where from? Oh, how does it work? Oh, it's not going to help us. So I will put that on the other side and we will start making things. Let's go into the library and we make a new file and we will call it core.cs because that's our core library. And I will say, hey, we will put this into the namespace of Novice Game. If I can type library. And then that is a public class core, which is actually derived from the game engine. And that is the XNI framework. Perfect, you've already done that for me. Thank you. But yeah, by the way, guys, if you've got any questions, do let me know on chat or hit me up in the comments down below. Always appreciated. And now we will go and make an internal. This is what's called a singleton. I recognize this pattern. S instance. We make a public property out of that. Static core actually grabs the S instance thing. Public static core. Oh, you need to name the variable, right? It gets a reference to the core instance singleton pattern. Now, to quickly explain a singleton pattern, essentially what that is you ensuring that there's only one single copy of your library, your software, or your function, or whatever. So you can basically make sure that if someone tries to make another version of it, instead of making that other version, you actually return our currently existing instance. So you can never have more than one core instance. Like this is fairly important in some circumstances, right? Because like think about it. Otherwise, you end up with two instances of the game engine, and which instance is actually dealing with what part? Like that makes no sense. You have one single core game in library. So now we basically go and copy parts of the dodge the boot stuff, right? We're basically making this graphics device manager, sprite batch. All this is going to move into the library, okay? And I will just keep going as the graphics device manager, and then we'll call this just graphics apparently. like so, graphics, and that has a getter and a private setter. Now, what that means, a getter and a setter, they're basically functions that you can say, hey, graphics, give me your content, okay? And internally, Microsoft, well, the compiler will actually make a function out of this nicely and actually return what comes out of this variable. But setting content can only be done within this library here. So this is why it's a private set. And let's actually make some documentation. Get the device manager to control the presentation of graphics. I can type. Okay, so then we need an actual graphics device. So this is also a public static new graphics device. And we'll just call it device, or I suppose graphics device. Again, with a get and private set. Okay. And that is, okay, gets the graphics device device to create graphical resources. And perform primitive rendering. So when we say primitive rendering, we don't actually mean it's primitive in that way. It's primitive, if I can type. It actually means we're rendering what's called primitives. A primitive is basically the lowest item that you can think of. In most cases, it's actually triangles. Like when we draw two screens in a lot of cases, we actually draw triangles, and they are the smallest thing that you can draw to that. So they are what's called a primitive. It's an atomic, even though there's a different word for it. But instead of saying, okay, we have this whole, say, picture and just dump that on there, you would actually have to break that down into individual triangles, and this is then what becomes the primitive out of the complex. Anyways, we continue with now making a sprite batch. Okay, cool. So public static sprite batch. And we'll just call it sprite batch because it makes sense apparently. Well, yeah, because we only have one instance of those. This, yeah, I can sort of get behind all this. Again, with a private setter. And get the sprite batch for all 2D rendering. So yes, I'm making this absolutely clear. We're not doing anything in 3D. 2D, the math thing is already difficult enough for me to understand. I have no interest in trying to understand, like, at the moment anyways, like vector maths, and just, no, please. You can't make me. So there's our sprite batch, and then we need a content manager to actually pull in like our assets. Again, we just, oh, that's a new content manager. Okay, that makes sense. Content manager, and we'll just call this content. And again, with a getter and a private setter. Private. Many wrong things were typed. Private set. Did we just get, yeah, extra library that we don't need there. And so this is essentially, yeah, gets content manager used to load assets. They call them global assets, but I don't know. We'll see. And then, yeah, here's now, oh yeah, here's where it's getting a bit more interesting. We now make an actual core instance. So let me go and copy this documentation, because again, I'm not going to copy all that or type all that out if I don't have to. And actually, we can make our lives easier. If you need to just make a constructor in any class, you just type ctor and tab. It automatically creates a constructor for you. And parameters in this case are string of the title. And then we take an int width. Oh god. Int width. Width. Int height. And boolean, basically a yes or no. Is it full screen? Right? I have an extra comma there that don't belong there. Cool. So now we're actually implementing the singleton pattern properly. So what we're doing is basically saying if is s instance is not null, right? We'll throw new invalid operation exception, invalid operation exception, and yeah. One does not simply make multiple core instances. Simply, why? Huh? There's that. And then we basically say otherwise, we refer to ourselves. Basically say, hey, the S instance, so this private thing of, okay, what is our instance? Who are we? Just literally comes from this, and this means essentially this class. This entire class core is also available as the keyword this. It is a very typical thing you see in our object-oriented programming. Another one would be self in other languages, but it's sort of always that concept of refer to yourself, so we can get a reference to that. And ensure we are truly singleton. And then we will actually assign, store the reference. Store reference to the engine, okay. For global access. Seid heute Nacht dabei, wir leben laut und frei, begegnen wir dem Tod mit Euphorie. Okay, so we now actually make graphics. So create a new graphics device manager. So this is essentially graphics is new graphics device manager referring to our own instance. Set the graphics defaults, which means we say the graphics preferred back buffer width is essentially our width. Okay, so this is now where we basically say, hey, I want an application in a certain size, like width and height, and we pass that in here. Graphics.preferred back buffer height is our height. Oh, yep. And then we basically say, hey, is this thing full screen? Is full screen. Okay. Then we need to apply the graphic presentation changes. and that is essentially graphics apply changes. Graphics.apply changes, sweet. Should be literally just that, yep, and then we can even set our window.title being just our title that we passed in from the outside into our constructor. And then content manager. Okay, so content is base.content. Okay. Set the course content manager to a reference of the base game's content manager. So this is basically just us inheriting that content manager from the XNA framework. And then we say content root directory. Root directory is content. You could name it assets, whatever you want. Like we could even in here for shits and giggles, because I don't know, content is too generic for me, whereas I think like assets is more descriptive to me. Why not? Extra space I didn't need there. Define root directory for asset contents. Something like that, maybe. And then is mouse visible is true. Okay. Mouse by default. Okay. And that is just is mouse visible equals true. That's one part. And now we need to also make the initializer. So, okay, you have problems. Oh no, you just, it's just a code style thing. And initialize the core library, and then we say this is a protected override. So we need to override this basically because what we're saying is we don't want to use just the normal base initializer. We want to make our own void initialize, base initialize, yes, and then we do our own little things somewhere here. Let me clean up. Set the course graphics device to a reference of the base game's graphics device. Okay. And that is essentially saying graphics device, graphics device is base dot graphics device, and then we need to make a new sprite batch instance. My god, my typing is terrible today. And sprite batch is a new sprite batch, and we need to refer to the graphics device, I believe. And that is essentially our core library for now. Since the MonoGame class, so it inherits all of the base functionality, which is what the colon game does at the top here. This is sort of this inheritance thing. And singleton pattern, this is exactly what I was talking about. Ensuring that only one core exists, right? Provide static access to the graphics device manager, graphics device, the sprite patch, and the content manager, and simplifies the game window setup with a constructor that handles common initializations. So this is interesting. So the new keyword in the property declaration, public static new graphics device and new content manager, is used to intentionally hide the inherent graphics device and content properties from the base game class. This creates new properties with the same name, but different accessibility, static versus instance, in the derived class. When you access core graphics or core content, you will be using these static properties, while base graphics device or base content within instance methods of the core class will access the original property. This pattern allows us to provide convenient static access to the graphics device and content manager throughout our game without having to reference the core instance every time. Okay, yes, I understand. Because otherwise you would have to basically in every function where you need to have access to the core library, you would need to actually make a variable that then instantiates that core. That's silly. That's why we do this in static program. Okay, so now we need to change our actual game class. Okay, so we now have core library. Let's go and save it, and we go back to dodge the dudes, and we need to go and change a few things. So first off, we need to say using novice game library, right? At the moment, we're not using anything, which is why it's grayed out sort of thing. But instead of inheriting from game, we actually inherit from core, and then that way we're already using it. We do not need these. Then the constructor, this is how we then call the basic constructor. We can get rid of all of this because all of this is set properly in our library. And then we actually see here how we make this window. So dodge the dudes is the name of the window, like the window title. That's going to appear at the top. And we make this apparently a 1280 by 720, and we say false. We don't want this to be full screen at the moment. Okay. Then initialize is still the same. Now load content, nope, do not do this anymore. And base load content. Then in the game update, or in the update function, we don't do anything. Like literally, there's not much to do here. And in the draw code, also no changes. Okay, so essentially we should end up with exactly the same output, like the gray window, but maybe we should also have a title this time. Let's see, what problems do you have? So they're all, it's literally just formatting shit. Huh? Huh. That was weird, okay. And I don't think this is right, by the way. Anyways, let's... How can I make this go away? Don't want no agent window, thank you. Interesting enough, I believe... Whoop. I think we should be able to just make clean, make run even. Oh, okay. We have errors. We have issues. Okay, so I'm noticing a slight problem here because I am. This is a meme. Basically, I don't have .NET 9 installed. I only have .NET 10 installed, and by default, at the moment, these are still running on .NET 9. But trust me, trust the process. This will work. That's the novice game library. Where's the same here? That should now be good. We're seeing a whole bunch of messages right now because none of the proper libraries have been pulled in so far. We shall do that right now. So first we'll say make clean. Nope, still not happy. Ah, yeah, runtime identifiers. I forgot about that. Why don't I Emacs no window? I don't want a GUI window. What I want you to do is go in here. I need the CS project file, so it's stream calculator app. That's the one. So there's this. All of this actually. Okay, that's not. Let me try. Do it this way. Yes, let me grab basically these 4 lines. Alt W. So that was from target framework, right? So we need to take all this. Target framework, runtime identifier, implicit usings off. I don't like that. So what that actually means, to quickly explain, implicit usings essentially means that Windows, or sorry, .NET will assume that a whole bunch of libraries are always included. Like it just includes them. It doesn't even tell you in your source code that they're being included. They are just included. And what I like to do is to actually say, I don't want implicit usings. I want them explicit. And that can sometimes lead to the software breaking slightly. But all it is, you just need the references to things like system.io, or like. It's basically just missing those references because it normally assumes I'm going to take all of system dot and just add it to the application, even though we may not need 3/4 of those libraries. So I'd rather do it explicit. That is one thing. So we have now the novice game library. Now need to do the same in here, where target framework, we're going, nope, are you kidding? Somehow I ended up with an empty thing in my paste there. Okay, missing XML comments. I'm quite aware of that. Let me go and clean up quickly our sort of, yeah, this stuff here. All the binaries and object files. We'll go and get rid of them for a second. Same here. Novice game library, binaries, yes, get rid, objects, get rid. Okay. Let's see if we can make. Good. Build succeeded. Oh. The error project file does not exist. Oh, yeah. We're looking for the wrong bloody directory because I haven't renamed. Where's my make file? Learning MonoGame, and it's actually called Dodge the Dudes. Yep. That's my fault. Make clean, make run. Let's try do this again. My god, that's already my first break time, and we have another error. Why? Project file does not exist. Home, workspace, repos, learning MonoGame, dodge the dudes, CS project. fine. It's fine. So I need to open the solution and basically we have the wrong references here in the solution as well, and we need to rename this directory as well, which should now mean Dodge the Dudes has a CS project file being renamed into the dudes.cs project, and this should now hopefully result in a full build. And it failed again. What did I do wrong this time? Why are you insisting on .NET 9? That's definitely not right. .NET 10. Net 10. There's nothing else indicating Net 10. Let me go and do another cleanup quickly. Might need to do that because it could have pulled in the wrong assets, well, packages. NuGet packages is.
Get in your bed. Put on the washing basket as soon as I put it outside. That's what put on it this time. Luckily, I didn't get the bolts.
Yeah. Clean all this up. Make clean, make run, go. Oh, wow. Wait, did I... Where's my make file? Of course that's not gonna work. Nothing else, right? Yeah, that should be fine now. Oh god. Please? Are you kidding me right now? NuGet restore with the runtime identifier. That doesn't sound right. Restore that. No. Okay, you apparently want me to pass in a runtime identifier. So what I'll do, I'll copy this line. Build runtime. Yep. Right. Might even need to do cleaning of the libraries as well. Let's see here. I would like to see at least one successful build before I go on my break. Why? And we have a bunch of warnings, and we have a game output window. Yes. This I like. It has a title. It's right at the top. Obviously, because it's a tiling window manager, you don't necessarily always see a title bar. But if you look at the very top of my screen, and you see the Dodge the Dudes mentioned there, possibly. Like it was right there. But now it's obviously it's fine though. It's fine. But yes, we have. Where are you from? Go away. Thank you. We have now a successful build. We just need to take care of some... okay. There's a bunch of things missing in core, but we'll look at that after the break. Guys, if you like this sort of content and you want to see more of it, give me a like, a follow, a subscribe. I will be back in 3 to 5. And then we will continue in our tutorial, which basically means next part is adding content, like adding graphics, dealing with those, learning all that. But with that, I shan't be long, and I will see you all very, very soon. And with that, I am back. So, yes, shall we... Thank you. Shall we maybe take care of all these messages here? Because you have a few complaints about me not documenting things, so let's document things. The main game class, the main game, just that's all this is. This is the constructor for that. So game constructor calling into C novice game library, right? And then here's the initialize. Initialize the game. Also calling into copy that in there. Oh, load content through Nova's game library, and then we have the update. And this is essentially calculate next frame. Like, that's essentially what we're doing here. This is what is game time actually for? It's its own thing. Okay. Game time delta t between frames. Then we have the same here. This is the draw call. Draw call after update completed. Like this, maybe. And this again is a game time construct. Delta t between frames. Between previous and current frame. Probably more apt to describe it thusly. Do a bit of formatting, save that. Why are you complaining about game one? That doesn't exist. It's like, let me open VS Code again. I have seen this before where it seems to remember old states. Okay, better. Don't need Docker, go away. Pardon me, couldn't see. Have you no other problems? You happy? I don't think so, but let me go and close the project files. We don't need those anymore. Yes, I knew there was going to be missing comments. The core game library, right? We probably need to document this. Internal static, no, not internal singleton the instance. Declaring it nullable or required modifier. What's the required modifier? Let's look into the message CS86. Where's .NET CS? Oh God. .NET. No. CS 8618. 8618. Configurable nullable context, no. Possible default reference of no. Because you're saying something about, well, let me read that again. The required modifier. Can we just search for that required? It's not even a phrase found on here. Seek. It might be easier to actually say that we're going to ignore nullable on the library. Control whether you can use a question mark to declare nullable reference types and exclamation mark to suppress. Haha. Because ultimately, if that went wrong, right, if any of this went wrong, then something bad happened anyways. Like, I don't think we are in a position to actually capture that properly. So why don't I... Can't do that. Can I do it here? No? So, what? You just said about exclamation marks. Annotation flag controls whether you can use to declare nullable reference types and exclamation to suppress individual warnings. Possible dereference of null. Yeah, I know that part. So this is where we basically say, hey, it could be a null and just ignore it. No, but the question mark indicates what again? To declare a nullable reference type and exclamation to suppress it. Okay, so the exclamation mark operator can't be applied to a variable expression or a method group, can't be applied to the left of a member access operator such as object field method. Feel like the solution is somewhere in this, but you won't let me do it there. No, it would have to be in here, but you're not accepting that. Okay, what if we just said, hey, ignore that? Non-nullable field S must contain a null when exiting constructor, but it does. What if I just... Gonna have to, I think, just assume that these are safe. Oh, that's triple. That's why that wouldn't work. Okay. Yeah, that's me. Put that summary in there, and then one more style change there, and we should still have exactly the same, right? Nothing should have changed. It should still run exactly the same. Should being the operative word. Let's see here. Cool. We have indeed a game window. Fantastic. Let's continue. So we are now yeah, we have all this done. This is fine. Now we do the content pipeline. Every game has assets, images to represent the visual graphics to players, audio to provide sound effects and background music, fonts to render text with, and much more. Like shaders could be a thing. Start out as raw files, which you will need to load into the game to use. So that makes sense. Loading assets can be done during runtime directly from file, or it can be loaded through the content pipeline. Both these methods are two sides of the same coin, and there are trade-offs to each approach. For instance, to load an image directly at runtime, you would need to add the image file to your project, configure the project to copy the image file on build to the build output folder, load the image file as texture at runtime using the texture 2D from file method. It sounds actually quite complicated. And this is actually interesting. So the major drawback here is essentially that when we present that image, it's going to be in a compressed form. PNG is a compressed format, and the GPU doesn't know that. So you would have to actually uncompress it or decompress it first, and then bring it back into the to the GPU, and that's just extra work. Whereas the content pipeline sort of takes care of that for us. It takes care of that for us. I can English, honestly. So let's actually just go through it. We have the editor built in, right? This is part of the extension pack for MonoGame. And I don't see it. So because I'm in the wrong project? No, like seriously, where's my... I should have a button for the content stuff. What's going on here? Yeah, base load content should actually point at assets. That's what we did, no? Oh, that's the wrong... base load content should be coming from core, no? Yes. Should be... And where's that? Initialize. Let me go and check my extensions quickly here. It's this is the thing, the MonoGame content builder. This is what we need, and it's there. I should have a button over here. Nope, wrong button. How? Maybe I shouldn't have closed that thing. Hey, Solo Frontier students. It's all good. Yeah, Unity is the one thing I don't want to go near at the moment because it feels too big for what I'm doing. With me just learning game programming, I'm sort of tending to go code first, like, which is why we're doing MonoGame. And then for the next stream, possibly we're going to go and try do Godot. Same thing, really, as Unity, just maybe not as, how do you say, as developed as Unity. Like, Unity has obviously got a huge infrastructure behind it and that. But you know, this is all just a learning experience, so. Yeah, MonoGame is, so, I don't know if you've ever heard of the XNA framework, but that's essentially what MonoGame is. And it's literally code only, and there's a really good tutorial actually here from them, docs.monogame.net, which really runs you through the entire process of making the game as well as making a game library for reusability, which I really like. I've just somehow lost access to my content manager. Content MCGB, that's the thing. Here's this. We need the MGCB editor, this thing. So, content. That's actually wrong. Well, yes. That's possibly why. Let me I'll try something here. Rename. Because I really would want it called assets, and just need to probably make sure that if we are referencing it, that we're referencing it right. But it seems we should be fine. Let's see if we can make this work. Yes, code only. But this is exactly the point. Okay, in my last 3 streams, I was making a calculator, literally just on a console. Let me actually show you. We have the example right here. Go to stream calculator. And this is essentially literally just a very simple text-based thing where we say, hey, give me a full math equation. We can use brackets to basically have precedence, and then we get an output where it tells me the tokens that it's found in the normal postfix order, infix order, so our normal way of explaining math, and then you see the postfix order, like once we've processed how this expression looks in both ways, and then with the result. So 3 plus 3 is 6, times 2 is 12. So this is basically what we did there. But yeah, that's... Oh, I was meaning to leave that open. It's fine. But yeah, so this is actually me just learning programming from scratch, essentially. That was sort of the whole point of this exercise, if that makes sense. I'm really enjoying this. It's sort of something else, right? I usually play Factorio, I play Satisfactory, or any game that sort of comes across. But I thought, I want to stretch my legs a bit and learn. Even old dogs can learn new tricks, I thought. At least that was the hope. So basically, this is our content editor, and I'll walk you through how we actually do things. And here's our first image. So what I like to do, I copy the image link, grab me this guy, we go into... Oh yeah, I need to go into the actual game first, and then assets. Now let me go and grab this guy here. So this is our asset manager, and here we're going to say, hey, I make a new folder. We'll call that just images. Thank you. Neil from Biffy Clyde. Oh, thank you for that. I guess I am for Scotland, but I wouldn't. Yeah, thanks. So now we have this images folder, which if I go and check this out in a console, we again have the same folder here. And what I like to do is just grab our logo, literally just dump it here into this directory. Oh, you're from South Africa. Nice to see you. I'm actually from Germany originally. Like I was born and bred in Germany for 26 years, and I moved over to Scotland in 2006. So that's where the accent is now coming from. But what we do here is we say we add an existing item, and you see our logo there. And then we should also say, let me just make sure. Existing item, open, and that's basically all we need for that. So what we do then is we save this asset library. We then also go and build this asset library. Basically what it does, it's taking all the assets and it's sort of bundling them up into a nice package so that MonoGame can just unwrap it all in the content manager. So thank you for this. We can now get rid of you. And our next part is to loading and displaying that asset. And this is sort of where they now expect you to understand your code well enough to just add lines in specific places, right? So first off, after we declared the class, well, actually, oops, going to make a new variable right here, sorry. MonoGame logo. And that is basically a private texture 2D, which we'll just call underscore logo. So whenever you see me using an underscore in front of a variable name, that sort of indicates to me that it's a private variable. So we don't have to rely just on the keyword. We can also go sort of through and see these underscored variables like, all right, okay, cool, it's private. No public access to it. And then in load content, where are we? Load content. This is content manager. I don't see initialize. Did I? Oh, I did this in the wrong place. This is actually the core library, and this is not where this needs to be. Cut that out there. This goes into dodge the dudes and belongs into this class. Right, and that means we have here our load content, so base load content. And then we'll say, hey, logo is essentially our, how do we do this? Content logo, okay? Oh. Content load. What kind of thing are we loading? It's a texture 2D. And then I believe I just add the name of the asset. So in this case, logo. Oh, actually, it needs to have a path as well. Images/logo, and you'll see actually, by the way, you don't see me appending PNG. That's very important because the content pipeline doesn't really care what the original format was. It just cares about the name, and it will then present you with the correct graphics there. Content maybe null here. No, just ignore it. It won't be. And then we need to draw it, right? And this is where we now go into our draw call. We're not really doing an update, right? We're not doing anything with the logo, which is why we can just dump this straight into the draw call and just say, hey, go and grab the logo and just dump it into a specific position on screen. So let me go and remove this to-do thing. We don't need it anymore. And we now say here, sprite batch begin. God, sprite batch dot begin. Sprite batch dot draw. And okay, so what are we drawing? The logo. Then rectangle, destination rectangle, and the color. And the destination rectangle in this case is actually not, I don't think it's a rectangle, it's a vector too. So the sprite batch draw has multiple overloads and multiple ways of calling it. Yeah, vector.0, vector 2.0, and then we say color.white. What's that color actually do? Interesting. So if I go and look at this draw call, if we can, color, what do you do with that color? Set the item, it just gets set for something. Okay, interesting. But so this is sprite batch draw, and then this is sort of important. We can't just leave it at that. We need to end that sprite batch. We need to basically declare that we are done dealing with whatever is in the sprite batch. And you will say like so. Say yes, I know it may be nullable, but it won't be. Trust the process compiler. Shall we go and try and build this? So make clean and make run. Let's go. What do you mean? Oh, I'm in the wrong directory. Okay, we have errors. So in Dodge the Dudes on line 14. Oh, this is meant to be a semicolon, not a colon. The non-nullable field logo. Just ignore it for goodness sakes, or even say like so, right? See again, let's have a look. Make clean, make run, go, do. Build succeeded, and look at that. We have now a game window, and we have our logo drawn in here. Cool. And yes. And then what we're now doing is we are making a... Oh no, we're not doing anything. That was just a little... This is what you could do. Now we're working with textures. Okay, so this is now chapter 6. As a matter of fact, you know what occurs to me? I think I would like this as a repository. I think I would like to keep a track of what we're doing. And I think I've made the project already. I just need to sort of delete and remake it because it was me trying and testing things out. Let me find... right, okay, it's under my own repo tree. You know what? Leave that there and we'll make a new repo in the actual org of the Novice Prospect and learning MonoGame. Following the tutorial on, let's go and copy that link. Something like that. It's not a template. We'll make a new repo for that. The git ignore should be .NET if you have that. No? Is there a C#? Okay, we'll need our own git ignore. That's fine. I can do that. And as usual, I am unlicensing. I don't want to license. I don't care. If someone wants to use this, use it. Give credit if you can, if you want. Basically, that's all there's to it. Create the repo. Then let me go and we'll now clone that into something new, and we'll do a bit of forth and back to clean that up. So git pull. Running mono, we'll just call it quickly and then we can do some renaming and pull. Git discovery across file. Not a git repository or any parent up to 1 git pull. Oh, it's not git pull, it's git clone. You're an idiot. You're an idiot. A certifiable idiot. Pulling comes way after. Okay, now let me go and do a bit of shifting and stuff. Here's learning mono, here's learning MonoGame. Let me go and make sure you guys can see what I'm doing here. And basically all I go and do is copy all of this, chuck it here, remove this directory, yes. Go back here, rename this now to learning MonoGame, because then that's a bit easier for me to understand. We are now probably needing to reopen VS Code, because otherwise I think VS Code will freak out. So we now have a bunch of code changes, but we probably want to make sure we have the right git ignore for this, which let me Goldberg. From here, I will just grab. Oh, there's a git attribute as well. Okay. This is fair enough. We'll just make that happen. So I'll go on emacs.git attributes. That's in there, and then .git ignore. And go back one, go into the git ignore file, will just give me the raw output. Oh, that's Godot specific stuff. That doesn't. It's this. I think this is sweet. Well, we'll take this. Where's my Emacs? Ah, yeah. Yank that in there. Close it. I feel like there's still stuff missing here that I would rather have in the git ignore. Oh, that's why. I'm in the wrong fucking learning code. That's why none of that was making sense. Yes. Git ignore. Nope. Yank that. Nope. That's not what we need. That's the one. Yeah, this looks a lot more like what I was expecting in this case. What else? Make file. Yeah, I think the rest is actually fine. Yeah. So cool. Back to chapter 6, working with textures. Let me go and put you on this side, maybe. I imagine we see that looks already much better. 17 changes instead of 200 odd. Just looking through the files if there's anything that should not be uploaded, but no, this looks fine. Initial commit after finishing chapter 5. Hey, penny aged. No, it doesn't look like Godot. Did I say Godot in my chat? In my stream? I'm sure I said
You
mono.
can go on to it, but not at the moment.
Yeah, I know. I'm saying MonoGame. No, it's not Godot at the moment. That comes in a future episode. Today I'm basically learning game programming with code only in MonoGame, and then once we've sort of got something working there, we'll do the same thing in Godot, follow the tutorial, learn, see how it all works, and then maybe do an asset flip of a game. Right, we'll see. But yeah, after chapter 5. Right, that's all there's really to it. Commit that. PGP sign it. And push that out into main, which actually I shouldn't have done. Oops. But yeah, again, it's not all that important. I can now go and make a branch here. create a new branch, and we'll call this chapter 6. Right, publish that branch out, sure. And basically now we are going to learn about how to render things with the sprite batch. So it can also change states that you may have set manually, such as when you're performing 3D rendering. Keep this in mind when mixing 2D and 3D rendering. Okay. So this is the code that we've made in the last chapter, like chapter 5. We got the logo to display. And now we are experimenting essentially with where we can put things. Okay. So it's a fairly straightforward change. Let me go and open Dodge the Dudes. And so here, instead of vector 0, we make a new vector. Right, okay, yes, I understand actually what we're doing here. So we make a new, yep. So this is basically now becoming new vector 2. Actually, let's make this a bit easier to understand, and we'll call this origin, right? Which means I need to make that variable quickly, and that is a vector 2 origin, right? Is a new vector 2. Which basically we're going to say is, okay, window client bounds dot width, right? Comma the window client bounds dot height. But I would like, how are you doing this? How does that? Okay, apparently you can just take a vector and times 0.5 f for float. How would that work? Now, the reason I'm wondering, and this is where my basic math really sucks, if we're being honest, let me make a new file here, and we'll just call it notes.md or something just for me to work in. But so a vector 2, if I understand this right, is it's essentially a number representing two numbers. So let's say in our case we're asking for width and height. The vector would actually contain these two numbers, right? And I think you would actually maybe even, I don't exactly understand vector mathing entirely, but I think this is what a vector could look like. But how, like this is a two-dimensional vector, but how would you just add, multiply this by 0.5? You know what? Why don't I just ask? Like, this is basic math, and this is stuff that we do need to understand. It's as simple as that. Multiplying matrices by a single float. Like, for me, if I think about this, right, and if I wanted to do any multiplication with another vector, like or with a vector 2, in my thinking, I would need another vector 2 to multiply against. So this is why I need to understand how this would work with a single value. Like, how to multiply matrices. Okay, so this is So to multiply a matrix by a single number, multiply it by every element of the matrix. Okay, so basically you take your single number and you multiply against each position in that vector. All right, because it's scaling that vector, it becomes a scalar multiplication. Understood. And this actually makes sense because 2 times 0 right? In this case here is 0. 2 times 1 is 2. 2 times minus 9 is minus 18. So this is how you do... Okay. It's just a scaling of that vector. Understood. Okay, no, that makes sense then. Let's also make sure I mention this source like properly. Well, that'll do. Actually, maybe even excuse you, like so. Please tell me I didn't stop my stream just there.
What?
No. No, I was in the OBS window and I pushed buttons. So here's this vector that we've made, right? And I obviously did this wrong in naming. Okay, so what is your problem there? What do you not like? The logo, the vector, and the color. Oh, you don't like that empty space there, fuck's sake. There. Okay, now where do we expect our logo to be? Think about this. Because what we're doing is we say to the logo, and maybe if I was to be a bit more clear about this, we open this logo. Like, where is it going to center from? Is it going to center from the top corner and then say, so rewind a bit. We have set the origin of the picture to be exactly at half point between the width and height. So we take the width, half it, end up somewhere halfway down the line here, and then we do the same for height. We end up halfway, and then that point right in the middle, that's where we are originating our logo from. Now, this is exactly the point. Is the origin of the picture the top left corner, the bottom left corner? Is it in the middle? We don't actually know. Let's see what happens. Make clean and all that. Where is it? Make clean, make run. Go, do. And okay, and this is exactly what I suspected. The image is exactly where we expect it to be. Right? Halfway between the width, right here, and then halfway between the height, right here. This is our origin point. It's the top left corner of that logo. Now, I believe there's actually a way to change that. So let's go. Okay, in the example above, we multiply the vector to create it by 0.5 to have the values instead of dividing it by 2.f. So this is actually very important. Multiplication is always faster than division. If you need to divide by 2, you're actually better off timesing by 0.5. That's still half, right? Yeah. That makes sense to me. Like I know this inherently somehow. Interesting. Interesting. So we can't change the origin of where we place it. Not, at least not from what I understand here so far. What we need to do is we need to take the entire width of the window. We then measure how big the logo is, take half of that, because then that moves us over to the left by exactly the amount needed to center ourselves. So, and I'm just on purpose trying to now create this for myself here. So the first thing I would like to do is, I think, just break this out into another line so it's a bit easier to read, because here we now say, oops, not the 0, minus logo dot width. Might be bounds dot width. I don't know why you are complaining about logo here. All right, okay, so it's not bounds. I did that wrong. It has a width directly. And then minus logo height. Wait, no. It's half of that. Why would you do it like that? Okay. Trying to visualize this in my head right now. Just for myself to just break this out into more easily understood values, what I'm going to do is we're actually going to say, hey, int x is something, right? Int y is something, and then we actually go and do that calculation in there, I think. Ich bin reich. Something like that, and then we can do the actual mathing here and say, okay, we need to first divide the client, the exact window, by half, so times 0.5, and then we take away from that the logo width times 0.5 f, needs to be a float. And this is going to be a float, not an int. That was me. You still say that there may be a possible dereference value. Fuck you then. We'll do it like this. Float y is the window's height divided by half, and the logo height times 0.5. And then I should be able to just fill in x, comma y, close. That's the new vector for the origin. Oh, some formatting. Sure. There we go. And is it that time again? Is that what you're telling me?
Will be in a minute.
Yeah, no, it's fine. I'm realizing. Okay, so let's think about this. Is this make sense? We want the logo to be really centered, right? So we figure out where the middle of the window is, and then we take away from that, from our exposition that we've already established, the half the width of the logo again to move over to the left, and that should align us perfectly center. Will it? Though. And perfect. Look at that. That's perfectly centered. I love it. Okay, cool. But yeah, we are making progress. We are, working our way through this. I'm gonna just leave that there because it is time for that time. Yeah, it's time for a break again. I can English, honestly. For those that are new to my channel, I take a break every hour on the hour. It gives me a chance to run some ads over on Twitch, take a stretch, get my wrist sorted again, and all that. But with that, I shan't be long, and see you all very, very soon. And with that, I am back. So yes, we have a beautiful MonoGame logo. Thank you, on the screen. And I believe, oh god, we're doing more things. We're doing more things with the logo. Now, my question really is here: do we need to do all this, right? I mean, okay, there's a bunch more parameters that you can pass in there. That's actually quite interesting. Wow, there's a few things that the texture draw takes in. We can rotate things. Okay. Maybe we should just go and do these as well, just so we get a bit of a feel for this, okay? Move you over here. And we now change the draw call. So the origin is still staying the same. So logo origin, then apparently we have a null value here, which is for the source rectangle, an optional region on the texture which will be rendered if null draws the full texture. All right, so you could basically say, hey, we'd only want like the front logo part or something like that. That's cool. Color white is still the next parameter. Then rotation is 0.0 f at the moment. Origin is vector to 0, which is the so-called origin. You can see this happening here in the tooltip. It tells you what variable we're actually working on right now. So the next one is like the scale, which is 1.0 f. So just leave it unscaled basically. The next one is sprite effects, so will the sprite effects none. And the so-called layer depth. So you can basically define layers below or above a certain texture, and so you can layer textures up to make a more complete picture of something. However, we want layer depth 0.0, I think. Okay. Let's go and do the formatting. That looks a bit better, and then maybe we can even texture to draw. Makes this a bit more easy to understand what we've actually put in here. So that's the origin, that's the source rectangle. For showing only parts of the texture. And color white, what is that? That's just the color, apparently. Like, I've got to know. I've got to know what happens if we say, hey, color green. Yeah, something, right? And that's the rotation. This is... So origin isn't origin. Let me go and make this, instead of origin, we'll call this position. Because apparently position and origin are two different things. So we now have origin. This one is the scale. This one is sprite effects. Of course, we have none at the moment, but that's fine. And this is the layer depth. I suppose if you need to do it like that, I suppose. Let's do a new build. And okay, interesting what it did with the green. I don't. Huh. I would like to understand what that coloring does, and I don't. What if I said color red? Whoops. Do that again. I think I can actually just make run. Oh, you do a full restore and that again. Oh, okay. Turns the whole logo red. Huh? So certain parts get changed in color. I almost feel like this is something to do with transparency in PNGs. It's fine. It's fine. But so we essentially drew the logo exactly the same way again. Yes. Right. Right. This is what I was thinking. This overload produces the same centered result, but exposes all parameters that control rendering for a draw operation. Unlike engines that abstract much of these details away, MonoGame provides explicit control for a flexible custom rendering pipeline. Here's what each parameter does. So position is the x and y at which the texture will be rendered relative to the origin parameter. Origin is the xy coordinates defining the position of the texture orphan. This affects the texture's offset during rendering and serves as a reference point around which the texture is rotated and scaled. Interesting. So rotation is a thing. This value is the amount of rotation to apply to the sprite when rendering it. We will rotate the texture 90 degrees to make it vertical. Okay, since rotation is measured in radians, not degrees, we can use the built-in math library in MonoGame to make the conversion for us by calling math helper to radians. Okay, let me try and understand degrees to radians. Like, how does that normally work? I didn't need a Google answer for the actual 1 degree, what that is in radians. I need the... To convert degrees to radians, multiply by pi over 180 degrees, since a full circle is 360 or 2 pi radians. What? So this is the angle we were working on. Let's say we want this 90-degree angle, right? I can't. I don't know that icon there. Let's copy it.
I'll let you out. You better not be an ocean.
I don't. Okay, no. Let me see if I understand this. Make it bigger. So this is the degrees we were working with, minus 30 degrees times pi over 180 radians. Cancel a common factor of 30. Why common factor? What common factor? Factor 30 out of minus 30. So that's basically assuming you know that 30 fits into 180, which is apparent enough, but still. So you get rid of the 30 as a common factor. You end up with minus 1 times pi over 6 radians. Right? And so that leads us, why? Minus 1 times pi over 6 is, yeah, it's just an inversion. If you times anything by minus 1, you automatically end up at the negative value. So that is simple enough. So essentially that would be minus pi over 6. So like 3.141 divided by 6 is the answer in that case, but why do we need to do this? I don't understand. But I figure this is probably a way of them simplifying that math in some way. Cool. So this is sort of an issue, and I don't want to say an issue, but it's something that you need to be aware of. Whenever you get into game programming, there is mathing involved, and it can be quite complicated math. I have never finished high school, so I have never learned half of these things. I just sort of picked them up on YouTube or, like other people talking about it, but I am not someone that understands all this natively. But that's fine. So like if we're wanting this to be a 90-degree rotation, I would say math helper dot to radians, and we just give you 90, like just a number of degrees in radians. Use math helper to radians. Gives us just the idea that in that comment, like this is how we do that. So by the way, if we now go and rebuild this, make clean. And there's our 90-degree rotation. Okay, makes sense. Cool. So the origin parameter determines the reference point from which the sprite is rendered, rotated, and scaled. By default, if no origin is set, it will be vector to 0. The upper left corner of the sprite. And this is basically where that rotation happens around. Yeah, that makes sense. That also means that if I set the origin, I'm just spitballing here. Shall we just experiment without looking further in this tutorial? Origin. Let's go and calculate an origin. And I think what I'm going to have to do is just to make this a bit easier for myself and not have multiples of the same variable. We'll just name these x and y position, and then we're going to make another float, not flout, a float, x origin, and another float is y origin, right? We now need to go and fill those out actually. So that becomes essentially logo, width times 5. And then we do the same with the logo height. So what we're now saying is that the origin is in the middle of the texture. That's how I understand this. So vector to origin is essentially a new vector 2 with x origin and y origin as their values. And then I would say here in origin, instead of vector 0, this becomes origin. Let's see what happens. We'll just grab you. Is that right? Okay, apparently I didn't quite do that right. Okay. It turns out that the position actually just becomes half the window, and because we set our origin ourselves, we don't need to do that mathing anymore. Okay, let me fix right here. Yeah, parentheses can be removed. I know that part. You're not doing it yourself. Fine, I'll do it for you. Just ignore that. Yeah, I feel like this is okay. Origin, position, let's see. Build the thing, do the thing, and let me see what we'll look like. Yeah, that's perfect. Yeah. Okay. That makes sense now to me. Because we're setting the origin for the texture ourselves, we don't have to tell the position, hey, account for that width and height, because we've actually set it to be right here in the center point and then centered it on the screen. Okay, sweet. And yeah, this is exactly the output we were expecting. Just to sort of confirm that I did this right. Cool. Well, scale is easy. That is like almost self-explanatory, but let's show it off, and I'm going to say, hey, we'll scale it to half. Okay, as we draw it, we only draw half of it, so to speak, or we'll scale it down by half, I should say. So if we go and run this, we should see the logo being much smaller in there. Right, that's, as I say, fairly self-explanatory in that case. All right, interesting. You can scale by a vector as well, which is going to look a bit weird because we're actually changing the relationship between width and height of the picture. So let me show you how that would look. It's a new vector 2, and we'll say well, is it time to apply a patch again?
Apply a patch.
Oh, come here then. Come see me, boy. Come see me. Oh, yes. Yes, we need to apply a patch, don't we? Yes. Doggo patch is always good. Yes. Such a good boy. Anyway, so like a real weird, we'll do something like this and 1.5f in the height direction. Like this is literally going to squeeze and stretch the image into weird proportions.
No. No.
Yeah, we've literally squished and squeezed that into eek. But no, this is cool. So we can scale in both directions. We don't have to just leave it as a single value like so. But this makes actually more sense because in that way we retain the proportions of the images. And now we go into sprite effects. So this is actually fairly straightforward. We could, for example, say sprite effects.flip horizontally. And I think I can just add another sprite effect to that. Sprite effects dot flip vertically. No? Or is it boring it together? Interesting. How? I'm an idiot. This is a comparison. It's the wrong operation. If we order together, it's like this. It's a single OR sign. Or pipe signal, simple. But now we basically say, hey, take that sprite or that texture, flip it horizontally as well as vertically. So we should see it upside down and mirrored. I think. That's not right. Or maybe it is actually. Yeah, no, we still have a rotation applied. Uh, do, 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 do. Let's leave this scale at 1f, so like normal scaled. I think we need to do 1.0f. So the f behind these numbers is basically just indicating that it's what's called a float. So an integer number is 1, 2, 3, 4, and a float number is something like 0.33, right? Floats usually are limited between 0 and 1, but all the values in between that indicate 0 to 100% essentially, right? So if I say 0.33, then you can also express that as 33%. Just as an example, but floats basically help you also take huge number ranges, compress it down to this 0 to 1 range, and make it easier for you to deal with those large numbers if needed. But that's just a very simplistic explanation. I may even be wrong. But it's now origin, flip horizontally, flip vertically. Right, we have, where's the rotation? Rotation is undone, so hopefully we should now end up with a logo that is somehow inverted and mirrored. Unless I did that wrong. No, that's exactly what I was expecting. So we've flipped it horizontally as well as vertically. Yeah, that makes sense. And then you can obviously say, hey, I don't want to do both. We'll take one of those away, take the OR sign away, and we literally just apply a single effect. So again, let's just confirm that. And there's essentially the horizontal only. No, vertical, I think. That's a vertical rotation, isn't it? No, it's a horizontal. I always get those two mixed up, but it's fine. Sprite effects 0. Or no, sprite effects none really, but I think that resolves to 0 as well. Yeah, but this is easier to read. It's not a magic number that way. And then we can do Yeah, this is sort of the color thing they were talking about. I'm not entirely sure if I understand it. So the color parameter applies a color mask to where the sprite is, to the sprite when it's rendered. And it's not setting the actual color of the image, just a mask that is applied on top of the image. Default color is color white. So if we're setting it to color white, why does it not affect the tinting of the sprite drawn? Good question. When the color parameter is applied, each color channel, red, green, blue, of the sprite is multiplied by the corresponding channel in the color parameter, where each channel is represented as a value between 0 and 1f. So this is the thing I was talking about, the floats. And for color white, all color channels are set to 1. So 255 in byte form. And yeah, if you take anything by 1 times 1, you retain the value. You're not changing anything about it. Yeah. And then we've actually done this color green already, and we've seen this applied. Interesting. I think this is now why things are black. So the icon and the word game in the logo look black after using color green because the red, blue, and green components of the colors are 0, 0, 0, 5, 0, 0. So half of green. When multiplying the component values, it results in 0f. Well, 0 times anything is always 0. So the first and third values will remain 0. And it's 0.5 times 0.23, which apparently is 0.125 in float. We can multiply the color parameter value by a value between 0 and 1f. Okay, so transparency is basically by multiplying the color by whatever transparency you want. So if you set 1f, like full 1.0, you essentially say it's fully opaque. And then the further down you go, the more transparent it becomes. So let's try that out. Here's color white, and we'll actually say, hey, I want maybe 75% transparency. Or opacity, really, it's 25% transparency in that case. I think you can sort of see it, but might be easier if we actually applied a different color to that. Let's say we go color green times half, or 0.75f, yeah. This should definitely lead to a different result than what we were seeing before. It wouldn't be just black and green. It'll be probably just slightly different shading, but yeah, no, you can see the difference here, and this is actually a transparent black. Cool, okay. Understood. Understand. And now we're coming to the source rectangle thing, and we spoke about this before briefly, where just from the description alone, it was clear to me that we can literally cut the picture apart into different parts. And so they've done us a favor here in measuring the pixels required to get each individual bit. So can we get a bigger version of this? So basically the logo itself is 128 by 128 pixels. Right, the text itself is 58 pixels high. It starts at 150 and 34 as the origin inside that texture, and is 458 pixels wide. Okay. There's our first rectangle, right? This is literally the logo, 128 by 128, starting at 0, 0, top left corner. And the word mark is, as we say, is 150, 34, and it is 458 pixels by 58 pixels. Okay. And we then add that as a source rect. Okay. That makes sense. Let's do that. Oh, good grief. Do we maybe want to clean some of this up lightly? I feel like now that we understand this variables a bit better, it'll probably be just as easy to say, hey, this is the actual values that belong in there. Right. Let me do like so. So that's the position. Let's set the origin just the same way. Okay, and then we'll make another vector 2, which is, well, icon source and word mark. Okay. Icon source rect. Is it a vector 2 actually? It's a rectangle. Ooh, that's different. A rectangle is a new rectangular figure, right? New rectangle, which location, point size, or x, y, width, and height, and that's what we're needing. Okay, so x and y is 0, 0, and we have, what's that, 128 by 128 as the size for that, and then the other rectangle that we're going to make is the word source rect. Source rectangle is a new rectangle starting at 150, 34, so 150 in the X position, 34 in the Y position from the top left corner, so we go 150 pixels over, we go 34 pixels down, that's where we start, and the thing is 458 by 58 pixels. Okay, word source rect and icon source rect. We need to do two sprite batch calls actually. Interesting. So this is not a logo anymore. This is actually. Oh no. Okay, it's still the logo, but where's the source rectangle? Here. Icon source rect. And then I think we just copy this draw call. And then this is now the word source rect. Okay, but we probably need to change positions slightly. Now position is wherever we want it really, and then the origin. Right. Because we need two positions for this. Oh no, the position is the same, its origin changes, I think. Word mark. Yeah. So we need to. I need to make two origins. Icon origin. Which is going to be you. And it's yeah. So not the logo height. So what we need to do actually here is we need to take that icon source rectangle, take its width. Yeah, take the icon source rectangle's height, and then times all that by 0.5f, or like half it, whichever way you want to look at it. Same thing. And then that's the word origin, which is the word source rectangle. Same here. Word source rectangle, and the position. Why are you not happy with this? It's just a formatting thing. Right. Icon source rect, word source rectangle. We still are printing the actual logo, but now the origins, where is it? Icon origin and word origin are now defined thusly. We have no rotation. Let's do color white with some transparency even. But let's not change the color, let's just leave it as is. think that's it. Shall we try it? Exactly. Why not? Now we should basically end up with the same looking icon, just in two parts. And yes, actually this makes sense. I think this makes sense because we've centered both around the window. Like, so the origins are set to do exactly in the middle, as well as the position. Right. And interesting enough, that is exactly the result we were expecting. So I did do everything right. We just, how do you then separate it out? So layer depth. Right, that's one part. So at the moment, as far as I can see, the word is above the logo, right? Which means if we were to go and tell the logo to be actually higher up, and we don't need to go 1F, but like 0.5F, just higher than the word, we should now end up with the logo being on top and the text drawn behind. That's at least the hope. I don't know, that doesn't look right. Maybe the transparency ain't helping me here either. So let's just leave it at color white, so we don't have any transparency and we can actually see which thing is on top. But I mean, you are insisting on 1.0F for this. Let's see. Oops. That's not going to make any output if I just hit F5. I need to actually run the last command. That's why nothing was happening. Need. Word is now on top. Which, let's revert that change, because theoretically that should then be underneath. Huh? Interesting. We don't see a change because we need to actually tell it how to sort sprites. If they're being back to front ordered or front to back ordering in the priority drawing. Oh, in the drawn. Okay, so we need to actually set a sort mode. A sort mode of sprite sort mode front to back. Okay. Sprite sort mode front to back, I said, you say, yeah? And then you're still 10F and you're 00F, which means now the logo should be on top. No, I don't know why you decided to do MonoGame install things. It's fine. It won't have broken anything. Not if it's already installed. And yes, now we are actually seeing that change. Good. So, order of operation matters. Interesting. Good to know. What else? Right, we've done chapter 6. Cool. Let me go and commit code. So we now have finished chapter 6. Like, that's all we really need to say to that. And commit that. sync that up. There's our project. Yes, quick pull request. We'll just merge this into main. Go do thank you. And then I would like to tell you that collaborators are trusted and we should now... yeah, it's merged in. Cool. So next thing, we check out main. We pull in all the changes. Cool, and then we go and branch off into chapter 7. Yes, So, optimizing texture rendering. We've learned how to load and render textures using Sprite Batch while rendering individual textures While rendering individual textures works well for simple games, it can lead to performance issues as your game grows more complex. Because now think about this. We've literally just drawn one logo twice because we broke it up into two pieces. That's two individual draw calls. And the more items you add, the more logos and little things you add, it's just going to get worse, right? Because these are all individual draw calls you're doing in that one update call, and that's just, or draw call, that's just not how you're supposed to do this. Every time this Sprite Batch draw method is executed with a different texture parameter than the previous draw call, a texture swap occurs, unbinding the current texture on the GPU and binding a new texture. This is literally called back buffering, I think. Right. Yeah, I can see how that would be absolutely silly. And then one approach to get around this would be to optimize the order of the draw calls to minimize texture swap. For example, if we reorder the draw calls from the previous example so that both paddles are drawn first and then the ball, the number of texture swap is reduced from 1. Okay, makes sense because the paddle texture is the same. We don't need to throw anything away. We just take that same paddle texture and we put it into another position. And that makes sense. That would be less draw calls. But we can do better. We can do what's called a texture atlas, right? And basically what that is, it's all the necessary images for your game. They're in one single picture. And then you tell basically an extra file, okay, I have a bunch of pictures, and here is their rectangles. This is where picture 1 starts. This is how big it is. Here's picture 2. This is how big it is. And this is what's called a texture atlas, and we can see an example of it here, where we load in this atlas, right? This is literally 1, 2 pictures. And then you would have an actual XML file. We don't see it here at the moment. That would actually essentially describe this picture and its elements, and then you just load that whole thing in one go, the actual whole atlas, and you just paint the elements of that atlas that you need. So that means we need to actually go and make something new in our library. We need to make a texture region class, and from what I'm seeing here, this is quite we have a lot to do in here. However, I need to quickly nature calls. It happens. I won't be long.
Patch. Hey, you just up. Come here. Lie down. Nobody at the door. Stop it. Stop. Stop! No. Get on your bed. In your bed. No,
Nothing going on.
there's nothing at the door.
I know.
That's what he's barking at.
There's nothing there. Maybe posting. Could be posting. Anyways, I am back. Do apologize, but you know, when nature calls you, you have to listen. Right. We are now making something new. We are my library. We make a new file, and this is a texture region.cs. Again, we'll namespace. Not like that. Thank you. This is novice game library. Public class. Yeah. Texture region. That's literally how we're calling our class. Oh, right. Okay. I whoopsie doopsie. Make a new folder, because this is actually a sort of subunit of our library. So we'll put you in there in graphics, which means that the namespace changes accordingly to novice game library.graphics. And then we have a few members. So we'll start with a public texture 2D. We'll just call that a texture, okay? Oh. And then public rectangle source rectangle with height. Okay. Public rectangle source rectangle. Public int width is, oh, I have somehow extra text there, that's fine. Width is source rectangle dot width, and public int height is derived from source rectangle dot height. Right? Get or it can't get or set if I don't set a getter or setter. Get set. Right, it's not a private set. I also did forget that same thing here. We need getters and setters for most of these. Well, 2 of these out of 4. Gets or sets the source texture. This texture region is part of. Then the source rectangle itself is boundary for this texture region. The source rectangle boundary region within the source texture. And this is literally width and pixels of the texture region, yeah. The I can type, honestly, sometimes in pixels of this texture region. Scale base. Oh, in pixels, not single pixel. I will copy all this commentary. Next thing, we need a New texture region. So we have two constructors apparently. Okay. One's literally just that without any parameters. Creates a new texture region. And then we do have a whole block here. Sick, no. We'll probably just move these over here, and then I can remove you and say we make a public. It's another C12 actually. Let's just make it easier on ourselves. And there's my function declaration. And now we need to add texture to the texture. Then you need what? X, Y, and width and height. Okay, so they're literally just int X, int Y, int width, and int height. God, I keep adding other libraries. Int height. Okay, and then we need to actually do something with all these variables and like assign things the right way. So we now do a normal association with the texture into the class. Like whatever texture has been passed in, we now take ownership of that, and then we say that the source rectangle is a new rectangle of XY with height. I'm sure. Yeah. XY width height. And that is apparently it. Well, then for this part, for the constructor. And you're not happy. This seems weird to me at the moment, but I'm just going to tell you to ignore it, but you can't. No. Yeah, we'll just ignore it for now. Now we need to actually make some. Oh my god. Oh my goodness. Oh my goodness. We essentially create the same function 3 times. And what I will do is get the comments in. And this is a public void draw. And then a draw, in this case, accepts a sprite batch. Right. We also accept a position, which is probably a vec. Yeah, vector 2, okay. Vector 2 0. Really? No, vector 2 position. And then the last one is color. What is that? Just color. What library does that come from? Yeah, because it should be coming from XNA framework color. Right, that's better because now it's just an XNA framework thing. Yeah, it's fine. And what is that? That's literally just draw. Okay. We basically get the sprite batch, the position, the color, and then we say vector to 0. That's the scale is vector to 1. dot 1. And then so when you see this vector 2 dot 1, it actually fills out the entire vector, or yeah, the matrix with ones in every place. Or at least in the places where it needs to be. I think there's like a order where like top left is 1, next one is 0, then in the second row, first one is 0, and the next one is 1. I think it sort of goes down in a diagonal. I seem to remember something there. And then we don't have any sprite effects. Dot none. And 00F. Boom. Now this is our first draw call, but apparently U is not happy. Sprite batch, position, color. Oh, 0.0F, I forgot a variable there. 00F, vector 0, vector 2, 1, sprite effects none, 00F, but you're still not happy. Yes, okay, so next. Basically, it's complaining right now because we haven't actually made the function that actually will accept all these parameters. So this is just public void draw again. And you know what? Fuck it. This I can copy because we can actually work through it and understand it. This is actually easy enough. So if I now go and add these, let me go and do some indentation as is needed. So what we're basically doing is we are creating a draw call that can be really simple. And literally what we're basically getting at is the initial call is just taking a sprite batch, the position, and what color you want. It then turns it into this huge draw call, which I'm sure 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. And so sprite batch, position, color, rotation, origin, scale, effects, layer depth. That's all the same. Okay, so you change the draw call here that when we get a scale in, right, you make a new vector 2 of these two scale values. And you are just the actual draw call that actually gets called at the end somehow. Like it all breaks down to this call here, essentially. Okay. Okay, that's literally us finished with this particular class. Now comes a new class. We make a new function, a new thing. It's fine. I can English. Honestly, my God, it's terrible today. New file, right? And it is called textureatlas.cs. And again, we need to go namespace, novice game library dot graphics. Within the add the following code for the. Yeah, we don't. No, this is fine. Let's just say public class texture atlas. And now we need some members and things. So first off, we have a private dictionary. Dictionary of type string and texture region. Okay, so we have a string and we have a texture region. That's the two types it accepts, and this is then just called regions. Oh my goodness, again. So we'll actually document this. This holds a dict of texture regions regions with their name. That's what I'm assuming that string is going to be. And then we have a public, oh, is this just, no, it's not. It's a public texture 2D called a texture. That's what we're going to name that variable. And that is a gets or sets the source texture represented by this texture atlas. Okay. And of course, if it's a getter setter, then I need to also make sure we actually do getting and setting. Then we have constructors and so forth, but yes, it is my break time, so with that I shall do exactly that. We will go on a 3 to 5 minute break, and remember, if you like this sort of content and you want to see more of it, give me a like, a follow, a subscribe, hit me up down in the comments below if you've got questions, all that good stuff. I will be back in 3 to 5. And with that, I am back. So yes, fantastic. We are now at this point where we've made the actual members. We now need to make some constructors and then some methods. I do like actually this a lot in this tutorial where they sort of break the class up into its components of the members, the methods, and the constructors. So you actually you don't get the whole file fed in one big glob. You actually sort of build it up the way you would normally build it up, and you would first declare your variables, members, like values that you want to hold on to. You would then go and make a constructor saying, okay, how does this class come into being? And then you make the methods that actually make all that stuff work together inside that class. So I like that approach. And then of course we're missing some documentation up here, which is holds texture atlas, atlas, and what kind of methods do we have? Clear, remove region, and handles it. Because there's going to be loading, there's all sorts is going to be happening in here, so that's fine. Let me go and get that constructor done. So first, CTOR. Oh god. Create a new texture atlas. Texture atlas. And we are doing in here something like regions is a new dictionary of string and texture region with no values being filled in. We just make that new dictionary that holds all our regions. We then have another one like that, but we will actually have it accept a texture. Can we just do CTOR again? Yes, we can. And then this is a parameter where we say, hey, texture 2D, I think. Yeah, texture 2D texture. And then we go and say, in our class, the texture is derived from whatever was passed in here into this constructor. And then we again do the regions thing. There's a new dict. Yeah, it's exactly the same construction now. Boofed. So basically what this does for us is we can just make a texture atlas and just have it prepared without any information in it, or we can actually pass a texture into this texture atlas and it then goes and loads it already. There's still stuff to do for that, but we were getting closer. Now we need to make some methods. And this is where it's going to get real interesting, okay? Let's see if we can put this together and understand it. First off, I like to just copy the yes, thank you. The the documentation, and we go and say we make a new public void add region. It does accept a string name. It also accepts int x, int y, int width, and int height. We then, well, that's fairly straightforward. So we texture, oh god, region. All right, we'll just call that region, and that's essentially a new texture region with the texture being passed in, the x, the y, the width, and the height, right? And then we add the just created region into our regions that we have prepared earlier on as a dictionary. Right? Oh, wait. You need a name as well. And that comes in from that call. Okay, understood. So far, so good. Making sure I'm not missing a chat. And next comes texture region, get region. So I will just grab this. Thank you. So as a public void, no. texture region, get region. All right, okay, so you actually return a texture region, get region, right? This is a public, so it needs to be camel case. Get region, and you just accept the name. So that's a string name. Okay. Oop. And okay, it just returns return regions of name. Basically, that's the key that we're retrieving. Now that's straightforward. Remove region, clear, they're also fairly straightforward. Let me... So this is removes the region, so clear region, right? No, remove region, so public bool. Why does it need to be a bool? We'll find out in a second. Public bool, remove region, and then that's probably just returning, yeah, well, it's just referenced by its name. And then we go regions. All right, okay. Return. Need to understand quickly regions dot remove name. So you basically have to return a boolean. Remove bool removes the value with the specified key from the dictionary, returns true if the element is successfully found and removed, otherwise false. This method returns false if the key is not found in the dictionary T key T value. Okay. We should probably do something in catching that a bit nicer, but I feel like that's a thing we can do later on. So that is a clear. That's actually really straightforward. Public void clear. It doesn't even take in anything. And we'll just do regions clear, I think. Yeah, that's exactly what we're doing now. Oh, yeah, of course, you want some documentation. Clears out the... Oh, removes all regions, yeah. Removes all regions from the texture atlas. Okay. Next, oh god. This is a function and a half. Basically, we need to interpret some XML, and that's always painful. Let me just check quickly. There it is. It's very bottom. Okay. Let me... There's a new function here. And let me go and grab its commentary or description, whatever. Okay. Public static texture atlas. From file. And it takes content and file name. Okay, so those are both strings. No, they're not. This is actually the content manager. Or from the content manager, and then this is string name, right? Or file name even. Typos. Right. Texture atlas. Atlas is a new texture atlas. I'm just typing this out, and then I will go through and explain once we have it all together. File name. So right now, what we're doing here, we're making a new texture atlas, and then we basically construct a file path, and what we're doing is path combine essentially takes any path that exists, or sorry, any path that you want to construct, add a couple of strings to it, and you can basically construct a full valid file path. So let's say, as an example, right, you basically feed in, give me notes for showing off. So say we have a path 1 and path 2, they're both strings, right? Let's just assume that path 1 is something like Windows, okay? Path 2 is system32, just as a word, okay? There's nothing special here. And when you then do a path.combine, combine between, it's right? In this case, we say path 1 and path 2 wants to be path combined. It actually ends up being C backslash Windows backslash system32 backslash, like it automatically adds the so-called path separators in for us to then construct the entire path for us, even though we may not only need to know the words. We don't need to know which operating system we're on. Like .NET takes care of that for us, so to speak, which is really handy. So this is what we're doing here. We basically get from the content manager the root directory that's being set there. And if we remember, this is actually, I think, in the core library, right? We have, where is it? The content manager here, right? And content root directory, we are setting it here, and as we are creating our library, our game library, so to speak, and we're actually saying, hey, this is assets. So it then goes and says, okay, where's the root directory? And then we add the file name, and then that makes the complete path. So that's how that works. Using, now this is a bit of a special construction here. I will go through that in a second. While we're using here in this line, stream equals, all right, title container dot open stream for the file path. Okay, no, you need to do like so, right? Basically what we're doing here with this using is we make a temporary instance of this stream thing, and the minute we've hit this bracket here, the entire variable gets just thrown away. Okay, so we're not needing to hold on to it, but we are doing another using because we now go and dive into the actual XML. So we're making using, again, we make this temporary thing, XML reader, and we'll just call this just reader, yeah. XML reader dot create stream. No, that's again wrong. We need to open another code block or statement block and x document doc is x document load from the reader. X document doc, then x element root. X element root is doc.root. You assume there may be a null there. Yeah, you're not happy with that. Okay. X element root is doc.root. me go and grab this commentary. So the texture element contains the content path for the texture 2D to load. So we will retrieve that value, then use the content manager to load the texture. Okay. So first we say string the texture path is root.element. We now basically search for an XML element called texture. And this is going to be essentially a snake-like game. If I go and I think it's in here in chapter 2, maybe even chapter 1. No. Getting started. Building 2D games somewhere. Yeah, here. Throughout this tutorial series, we will build a complete called Dungeon Slime, a snake-like game with a dungeon theme. By the end of the series, you will have created a polished game with smooth animation sprites, responsive controls across keyboard and gamepad, sound effects, background music, UI menus with customized styling, and a complete game loop with scoring and game over states. Right, this is basically what it's going to look like, but we won't get quite there, I think, today. There's a lot to do. But yeah, this is what it's going to look like. And if you are curious about what we are going to do in Godot, we essentially will end up. Where is first 2D game? And it's going to be called Dodge the Creeps, and it's essentially we need to dodge flying and swimming and walking guys, and when you hit them, it's game over. So that's going to be the Godot project. But right now we're working on Dungeon Slime. Actually, why I named it wrong? It's fun, but there's a lot to do still. Right now, we're just bootstrapping some graphic stuff. We're literally just learning how to read graphics in, and like it's going to be fairly interesting because what we're going to end up doing is instead of loading individual graphics, we're going to do what's called the texture atlas. And essentially, it's a single picture with all your elements of the game in one picture, and then you describe in XML exactly where each element of this picture lives. So like this Pong example, not what we're making, but this is just to show this is the paddle, this is the ball, but this thing gets instantiated twice. One's on the left, one's on the right, and then you have the ball going forth and back, but you have it in one picture, right? And that's what we're basically learning right now, this whole texture atlas thing. That's exactly why I'm doing it, Spetno. That's exactly why I'm doing it, because yes, I could have also sat there and says, "Oh, I want to recreate Flappy Bird," like, just as an example. But without even knowing and understanding how to even make simple graphics appear, how to like do collision detection, movement, and all that, there's no point in going big. Well, you may. Not everyone does. Right, and again, this is sort of the whole pathway for me to actually learn this and internalize it better. It probably isn't, but if you have no idea where to even start with any game, then you need some starting point, right? Which again, when I did the stream calculator or the calculator, that was for me in my mind sort of the one of the easiest things I could somehow put together, right? So again, this is all about me just learning this and having news on the journey. Yeah, it's really hard when you don't know how to do it because you don't even know where to start to figure out how do I make it easier, right? So I find it quite important that we actually go and learn this step by step and figure out how we do things. I forgot about value here. So that's this texture path, but we now need to actually get the actual texture out of here, which is content load, and it is a texture 2D that we're loading. Content load texture 2D, and then we give you the texture path. Okay. Again, a massive comment here. So let's... So the regions element contains individual region elements, each one describing a different texture region within the atlas. So this is how this would look in XML. The sprite 1 starts at 0, 0, has a width and a height, and then the next sprite is wherever its origin is, again with the same width and heights, for example, if you have like same-sized elements. So we retrieve all of the region elements, then loop through each one and generate a new texture region instance from it and add it to this atlas. Okay, interesting. So var regions is root.element, and I have no clue about XML, so this is why I'm just blindly copying most of this. Elements region. Nope. Yeah, this is a line that I'll be honest, I don't quite understand. I understand that we need to read from the root of the XML document a regions element. But why gets the first in document child element with the specified X name? Oh, yeah. No. Look. That this is mean. We have a declaration for all the regions, and this is, we're seeing this here actually. This is regions, and within regions we have individual region tags. That's what we're doing. We're looking through the root for regions, and then loop through the individual ones that are mentioned in there. Okay, cool. This, again, is also why I'm not just blindly copy-pasting code. I want to understand the lines of code that I put down. What do they do and why do they do it? Right? Commentary is all well and good. It's good to have, and it really explains, the code maybe a little bit better. But, like Soaring likes to say, and I like this really a lot, the best documentation you can have is the source code itself. And by that token, you need to write your source code in a way that is easily readable, so you don't want to make long statements all the time. This is why you've seen me earlier on breaking up certain statements into multiple lines and that. But by the same token, when I just put the code down, I need to also understand it. So this is why I find this really, really important to do just this way. And now we're looping. First off, we're saying if regions, if regions is not null, right? We need to make sure we have actually a value in there. Hey, Baro, you made a game in Python. Oh my god, no. Also, I won't just download random code from the internet. As you can imagine, that is just not a good idea. And besides, I'm not here to test games. I'm here to make games, or at least learn how to. Well, how you doing, Baro? Nice to see you. But yeah, if I hear Python game, I'm thinking straight away of RenPy games. Visual novels. Yeah. Okay. No, you feel free to mute me all you want, Smet. No problem. But yeah, just take care of yourself, And I was saying this before, Smetnal. Make simple things. Put them on a GitHub or Codeberg, whatever you use for your version control. But there's your portfolio right there, and this is how you probably might even get into a position where people look at it and say, "Hey, someone knows their thing. Hey, maybe we can employ him." But the easy, you find it a lot easier if you actually have things living out there that you are a part of, that you've created yourself. Like in my case, for example, I am quite proud to say that I was involved directly in the Docker implementation and Linux implementation of the Steam Server UI. Right, so this is something that would be on my repo if I still had access to that. Thank you so much, Baro. But yes, we are now checking here for regions and all that. We are basically saying if we have something in regions, so we've actually found something, then we're actually going to do some processing. So we say here for each. Okay, Baro, take your time, and thank you so much for dropping in. YouTube as well.
Yeah.
I had already said. Yeah, I've already said them. So for each, what are we doing here? For each region in regions, okay? For each region in regions, and I don't want to have implicit typing, please. This is excuse you. Maybe I need to leave it just implicitly typed for now, but this doesn't feel right. Not sure what's going on here, because normally you can say, hey, turn that from an implicitly typed thing to an explicitly typed thing, and I don't see it. Okay. For each region and read. Var region and regions. But you say you can't for each that. Cannot operate on variables of type X element because X element does not contain a public instance of or extension definition for get enumerator. It's X document load reader, and then X element is the root, and that's derived from doc root. Not sure why you know likey. For each region and regions, we basically say string name is region dot attribute. Oh God. No, wrong. That's meant to be double quotation marks. Var regions is root dot element of regions question mark dot elements. That's why. Yeah. That's that, because it's otherwise it's a single element, not multiples. That's why I did wrong there. So that's now fine. You converting null literal or possible null value to non-nullable type. We'll probably fix afterwards. Int x is, my God, int dot parse. God. Region dot attribute x question mark dot value question mark 0. Right. Okay. So what's happening here? This weird double equation. Sorry, double question mark notation is essentially saying we try and parse an integer, right? If the integer was parsed, we put this value in, the actual x value that we've retrieved from this attribute. Otherwise, this is sort of an else, put in 0. Okay, that makes sense. We do the same again for y, and say, okay, obviously now pull the y attribute from that region, or return 0. And it's the same for width and height. So width, region attribute width, probably lowercase, right? And then again, we say, hey, otherwise set the the value to 0. And width, height, okay. And then we go and say if string dot is null or empty, right? For name. So if we're not finding an empty string, then we actually say to the atlas.addRegion, hey, we have a new region for you to add, right? And this is its region and the texture region's name, and here's the values of where that thing is supposed to live and how big it is. Okay, then that is essentially after we've confirmed. So right here, I would then say return that entire atlas. We can probably say, hey, this may end up being a null value, but trust the process. And now we're actually getting to using that texture class. Ooh. Using the texture class, so this is the texture atlas that we need. Copy image link. Let me go into, yeah, I hate this already because I got names wrong. It's not Dodge the Dudes, this is, I keep forgetting things. Gonna need to rename this. I just don't. No. We're not. No, this is the wrong project, and this is just me mixing up things in my head. It's fine. Slime dodge, I will call it. Solution needs to have the same change there. Boom, boom. We'll probably need to reopen the entire solution in a minute. No, that's the game library. That's not what I'm needing with here. This is fine. Okay, you can close that, which means now I just need to go into here and rename the class and constructor. And then in the very construction up here somewhere, where is it? Blah, 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 blah. It's something like that for now, right? I don't care. Nope. So A, then sweet. Let me go and do a big cleanup quickly. because there's now going to be references that are not going to work, so it is easier to just clean out the object files and binary files. Assets has the same problem there. Get rid of the object file there, and then we should be good to go. Assets, images, wget this. Nope, not that. Copy image link. No, something's wrong here. Something is wrong. Oh God, what did I do? I did a thing. Oh man, what? No. So we should now have an Atlas PNG in here. Sweet. Now we need to go and actually let me go and reopen the project properly. Yep. Oh, jeez. That's why. Okay. Now comes the question. That's not going to build right now. But where is assets here? This is I need the this guy. Open up. Open wide. Images. We now add another existing items, which is our atlas. Okay, we save that, we rebuild the content library, and thank you. Can even see how it's importing them. That's really cool. But thank you. We now have the texture downloaded. Okay, now we go into the game and start changing things there. Slime dodger. We need to make 2 texture regions. There's quite a few things we need to go and create and then change, but yes, this is actually cool because we're gonna start seeing our own textures here. First off, we're gonna get rid of the logo. We will not be using that in the future anymore. So that also means that I'm gonna not load that content, which also means that we don't do these draw calls. Both of them go away for now. Right, we will obviously have to make another sprite batch draw call here, but that comes once we've actually loaded the new textures in. Let me. So we now need a private texture region. We'll just, that's the slime. Then we might make another private texture region. And that is that. Okay, and now we go and in load content, we now do this properly. So let me get rid of this commentary here. Let's texture 2D. Atlas texture is content load texture 2D. That's the type that we're loading, and then what we're grabbing is images / atlas. Again, we don't need the file name ending because the content manager will actually infer that itself. Texture atlas. Make a new atlas here, right? Which is a okay, new texture atlas from atlas texture. Okay, then we make some regions. So atlas dot add region, and that is the name of the region first. That is the slime, and it lives at 0, 0, and it's 2020. Okay, 0.0.20, That's the origin of where we start measuring the texture, and we go 20 pixels along, 20 pixels down. That is our first one, and then we probably want another region for the bat. For that. So that is the name there, and it starts at 2020, and it is also 20 and 20. So literally just, oh no, 20, 0. So we remain with our origin at the top. We just go over to the right and then read the next 20 pixels in. Okay. Then I'm going to say slime dot, no, slime is atlas dot get region. Which we are, putting in that name. And the same should probably be true for the bat. It's atlas.getRegion. And then again, we pass in a name. This is the bat in this case. We thank you. So we now have those contents loaded. We just need to tell the draw call to deal with that. So first off, let's clean up some of this as well. We don't need actually any of this. We don't need the sources, the origins, none of that. Right, we sprite batch begin. Oh, okay. We do need to do something slightly different. This is sampler mode. Oh no, sampler state is sampler state point clamp. We'll probably get that explained. And oh wow, this is actually cool because now what we do is we just refer to the slime and we call its own draw function. Oh, I like that. So first we need to obviously attach it to a sprite batch, which we already have. We then vector 2.0, which is the position. Sure. And color is color.white. No, not wheat, white. Then point, that's the that's the rotation, sorry. 0, 0, F. Next one is the origin, which is vector 2.1. Why? Anyways, so scale, you want me 4.0 F? Yep. And then no sprite effect. And so that layer depth is also 0, 0. Okay, then we do the same for the and then we do the same for the bat. Bat.draw, bat.draw. Almost feels like it's pretty much the same, except for probably changing the origin slightly. Let me see here. Right, okay. So this is, let me do a bat origin thing. Var bat origin is essentially a new vector 2 of slime width times 4.0 F Right, that's actually accounting for the scaling because we've made it 4 times as big. We now need to account for that with times 4. Plus 10, so we're moving it over a little bit. Comma 0. So we're still staying on the same y coordinate. That's about origin now. And okay, we need to do a bit of layering. So this goes on top for some reason. Oh. Okay, that's just formatting. You want it that way so it's easier to read. I can actually get behind that, to be fair. I think that's it. I think that's it. I think we should end up now with a make run. We should now end up with the 2 things up in the top left corner. First the slime and then the bat. Nope. Oop. Ah, yeah, yes. Make file needs to be adapted because where's my make file? Make file. It's not Dodger Dude, it's Slime Dodger. That's a me. Whoopsie doopsie. And we have errors. Semicolon after method or action is not valid. So texture region, line 11. My God, okay, we have a few errors. Texture region, line 11. Yes, no, this is nothing. That is definitely not a thing. Do we have? Can you show me any more problems? Where's? Is it you? Yes. Problems. Same problem I did have there. Then I'm missing a texture region comment here for the public facing documentation. This holds an entire texture region for texture atlas atlas usage or about something. Then you're not happy with that because not nullable, but I don't think I can. Nope. I don't think we can tell you to just ignore that. I don't see that. Where's texture to the texture region? Yeah, no, I don't. Okay. Non-null of it must contain a non-relevant exiting constructor. That should just work. And we've already imported our graphics library here, which is cool. I think they should actually build now. I think the actual build errors are gone. We just have more warnings, but I can't take care of all the nullable objects. And we still have an error. Okay, what did I... Texture Atlas line 131. Okay. Oh god. Oh god. Trying to see where my brackets are breaking down. But that is referring to that bracket. I don't... The namespace itself isn't... It's file-based, it's not scope-based. So we're closing that bracket. Mm-hmm. I think that if hasn't got a proper closing. So I need to actually do this here, and that's where the return atlas needs to be as well. Yeah, bunch of hold null reference complaints, but I don't really care too much about those right now. Can we... Oh god. Please make this. And I have changed scenes. There we go. And we have another error. Oh god. Where did I do that? Slime.program CS. I really buggered up this code a little bit. Oh right, okay. Running MonoGame dot slime dot Why? Oh god. Can we turn this into a normal? Yes. I want a proper program structure, please. Thank you. Right. See again if we... Yes, should now build. Should being the operative word. Yes, we have 9 warnings, but there's our 2 textures. We have a slime and we have a bat. They're not doing anything yet, but they exist. Woohoo! Yes, yes, yes. Oh my god, are you...
No, I'm not playing.
Are you doing something to time? Are you
No.
compressing time somehow,
No.
making it so I don't get to... I don't know. But yeah, guys, with that, it's time for my break again. So with that, if you like this sort of content and you want to see more of it, give me a like, a follow, a subscribe. I will be back in 3 to 5, and then we shall continue our adventures in textures and atlases and contents and what have you not. I think the next thing would be to actually make this not coded, because right now, if we look at the slime dodger here, we actually make these regions ourselves here. We're not somehow retrieving it, right? We're actually saying, okay, this is the pictures, this is hard-coded values. Let's maybe do that better. And that is exactly what we're going to do after the break. And with that, I shan't be long. And with that, I am back. So, as we were saying, we have this texture atlas thing going on, but we are manually adding these regions as we are coding. Now, the way you're supposed to do this is you do this in XML. You basically make a description of this texture atlas, and let's just go and do that. We have, where's our content? Assets MGCB. We go and open the actual MGCB editor. And this now goes, okay, you have this just living in images apparently. But we make a new item this time, and it's just XML content, right? We'll create it. Oh, we need to name it. And, okay, atlas/definition.xml is the name of that file we created. It will need to be told, however, that you're not going to build. You just get copied into the directory where we're going to end up with our binary. So again, we save this content pipeline, we go and let it build and say thank you. Also, let's go and I think exclude from project is all I need to then save and rebuild, which also means it's cleaned out the logo. Perfect. Love it. Now comes the actual content of that. Where is it? In images, we have atlas definition, and we have already something here. We don't want that. We go and overwrite it. And now, if you look at this, this is exactly the same definition that we did in code. So where's my let me clean up my oh, I needed that open. Damn it. Atlas definition. There's the slime dodger. Cool. So if we look at this, add region, slime, there's the name, 00 is the origin, 2020 is the width and height. And if we go and look at this XML, it's exactly the same. We have a name, we have an X, a Y, width, height, with those values. But, you know, saying, okay, that its origin is actually 20 pixels over. Okay. So this is one part of this. And then we need to... Oh, very easy, actually. I love it. So we go into load content. Okay. We texture atlas. So I don't even need this line. We literally just say a new texture atlas. But it's actually not new. It's a texture atlas from file. From file. Oop. And it will be told right, okay, this is actually telling us now the definition of that. So we need a content manager and we need a file name. So, you know, this is literally just content and could be a capital C. And the string being, okay, just atlas/definition.xml. Now, very important because it's not an image, so the content manager doesn't really know what to do with this file. It doesn't know, or it's an image, you know, I'm just going to look for that image and then do the decompression myself. XML files like this, you need to actually be adding that ending, that extension, like .xml needs to be there, otherwise it won't find the file. And then it's literally as simple as slime atlas get region and bat atlas get region. I think literally that's all we needed to do there. Create an atlas, let be from, yeah, remove the manual creations, yeah. Oh, thank you. Now, theoretically, we should end up with exactly the same result.
You might have to apply a patch.
Oh, do we need to apply a patch again? Oh, come here, boy. Come see me. Oh.
Everything. He's not peed on the wash neither.
Oh, good boy.
Just washing back.
But look at that. We actually have indeed exactly the same output, but now we are in a position where we can just extend this atlas definition with more icons if we wanted and needed to. Love it. So this is basically chapter 7 done. So let's go over to chapter 8. However, we've done code changes. Let's commit those.
No, you go play. I don't want to play.
And this is a fairly big change set. And let's go and create a message for this. Refactor. Refactor and chapter 7 done. And we're going to say refactor was essentially rename game to Slime Dodger, and then implemented texture atlas retrieval and usage.
You play. You go play.
So commit that as a big change. Nice.
That's not playing.
No, I'm doing my own playing here. And we're going to sync that out. Oh, you may or may not be. Oh no, you've done that. Okay, cool. Let me. Oh. Timberborn?
Uh-huh.
Did you install it from me?
Uh-huh.
Alright, I was going to say you didn't buy it.
Buy it.
No, I didn't have to.
I don't.
Exactly.
Just install it.
Exactly. Chapter 7. Let's go and do a new pull request for that. Pull that into main. And create a merge commit for that. Enough, patch. Seriously. I've still got another 2 hours, so you better not.
You're fine. No, you're not.
Right. Chapter 7 done. Nice. Let's now, the usual, we'll check out main. Right, and tell it to pull in all the latest changes from there. And I like to see this, like this was chapter 6 merged in, chapter 7 merged in, so we can sort of work our way through these chapters and follow that progress. This is now chapter 8. Okay, just push that out as a branch. I don't care right now. So we now have, we're now dealing with so-called sprites. We've learned how to use texture atlases to optimize rendering performance. While to solve the issue of texture swapping, managing individual sprites and their properties become increasingly complex as your game grows. Yes. Yeah, this is then all the properties that we would need to keep track of and changing all of that. Fair enough. And apparently, sprite represents a visual object created from a texture region, along with its rendering properties. So you sort of combine all of that into a single class. Nice. So we shall have to create a new part of our library. Okay. And so right now we are not working in the main program. We're working in the going to say the files should be there. Ignore Slime Dodger. We are going back into graphics. We're making a new file in here, and this is just called sprite.cs.
No.
And we go and place this in the namespace of the novice game library.graphics. It's fine. I'll need to finish.
No. Enough. He's fine.
No, I'm not going to do this for another 2 hours listening to that.
No, I'm going to take him out.
Not going to change anything, but yes, public class sprite. That's what we're going to make, right? So we need some properties. We need a lot of properties. Wow. You know what? I will, in this case, copy and paste it. And because here's the truth. None of this is really all that complicated. We can work through it. Like this is sort of I like this expression. This is what's called rubber duck debugging, right? You're talking to an inanimate object. In this case, I'm talking to chat, but it's still sort of that same idea, right? Where we're just sort of going through and understanding what we're actually reading. So we need a texture region. We need some color. Usually it's color white, but we can set a different tinting color. Rotation. And there's scale, which is normally 1, so we can again override that. Same as, what's this, the origin. This is the sprite effect, which is normally sprite effects none, and you cannot see those. Well, let me give you some references to use and work with, right? So there's our sprite effects, layer depth. All of this is literally the normal stuff. Interesting. Gets the width in pixels of the sprite. With this calculated by multiplying the width of the source texture by the x-axis scale factor. Which is something that we pass in further on up here. Right. And then you do the same for the height. Love it. That is, this is self-explanatory. And like properties, really just think of them as variables existing in that class that you can just refer to from the outside. The next part is super simple. I will, however, type this out so we get this right. So we need a constructor, but we need another constructor. Right. The first constructor doesn't take any parameters. Right. It didn't literally take anything in, but we will say that this is the creates a new sprite. This is what this constructor does. This, however, will also accept some parameters, and it's actually just one, but okay. Creates a new sprite with the specified texture source texture region. All right. Parameter name is going to be, God, how do we? Name is region. So that is literally what we're going to do. Texture region, calling it region. And then we literally just set region in the class equal to what came in from the constructor. Boom. That is easy enough. And now we're having two methods. That's again fairly straightforward. Let me go and fix the formatting. Thank you. We now have a public void center origin. And that basically says origin is a new vector 2. Okay. This is literally what we've been doing before. We measure the texture region and we just take half of it. So region width, comma region height times 0.5 f. Boom. Right. Sets the origin of the sprite to its center. Hey, files! I am making nothing really. I'm following a tutorial. First off, hello, welcome in. Basically, I'm learning game development from scratch. We have in previous streams, and you may or may not have missed that. Let me go and show you what we've made before. Right, because I was learning programming sort of as a starting thing, just learning stream calculator. If I go and say make run, we basically, it's literally just something that takes in math expressions and turns them into a result. But this was difficult enough to figure out. And this is going to look interesting. So we're going to say here 3 plus 3. We can even do bracket notations. Like I love that. Times 2. So this should lead to 12, right? 3 plus 3 is 6, times 2 is 12. So this is essentially what it's doing. It tokenizes the entire expression, saying, okay, we have a left parenthesis, we have a number, we have addition, and so forth. But for a computer to properly do this math, you need to actually change the order of operations to what's called the postfix notation. So instead of 3 plus 3 times 2, it becomes 3 plus, right? Basically think of it as a stack, and then you're coming in from the top of the stack, and you're looking through it, and it's like, okay, we have a 3, we have another 3, then we have a plus. So that's our first operation, and that leads to 6, which then means that internally it would say 6 2 star, basically saying take the result of the first operation and then keep going through. And this is basically what it did. It resulted in 12. But that was just me, learning basic C# programming and figuring things out. And then I've decided, you know what? I like games a lot. And how about we learn how to do this ourselves? And here's the point. It's so easy for us as gamers to sit there and rage on about games. This isn't running right, this is too slow, it looks horrible. Go and make a game yourself and then tell me that again. This is the position I'm putting myself in. Instead of constantly raging and complaining about games, let's try and make one ourselves. I mean, how hard could it be, right? It's just game development. Make no mistake, it's fucking hard. Like, especially for someone that's never finished like high school. I've never done any of the sort of higher math that you need. I didn't know what a vector is. So like this is all me learning. Hold on. Yeah, I'm having a ton of fun with this. So at the moment we haven't got much, but we do have something that we can make appear on the screen. And yes, I am using CMake as the make file, the make system from GCC to build a .NET app. It is horrendous. It is horrific. It is a violence against nature, and I love it. But here's we have basically 2 objects loaded in, and we display them. Now, what we've just learned actually here is that if we and this is sort of that was the last chap that we just did. If I look actually at the actual image that we've got in here, you can see this is actually multiple images. How do you go back out? How do you zoom out? Yeah, you apparently don't. But the point being, we actually load in this texture first, 20 by 20 pixels, and then it goes over and loads in this texture, but it's all from one picture, and we just cut it into little regions. And you can see the other frames in here already. They are basically meant for animations, so we'll walk through that as well. We'll learn animations. It's fucking amazing. And the reason I'm doing this in MonoGame to start with, because I like code. I understand code quite well. Whenever I look at something like Unity, Unreal Engine, even Godot, I feel out of my depth because you're straight away dumped into this 3D context, and you're like, what now? What do I do now? So I felt it quite important for me to learn the basics of game development, like what is a sprite, what is a texture, what is an atlas, all these things, before I then jump into a full-fledged game engine that's going to throw all these concepts at me, and I'm going to be absolutely lost. So I'm sort of taking a step back, learning graphics from the ground up, game development from the ground up, and then in the next, probably not next stream, it's the stream after, I will then go open up Godot, go through that tutorial, and the big plan here, the plan at the end of it is that we take that same Godot game that we've made once, and we try and recreate it without the tutorial, but with our own assets maybe. So because I want to also learn about maybe doing pixel graphics, again, this is all to prove that this is hard to do, right? It's so easy to complain, and I really encourage anyone watching, go and make a simple game. Make Pong if you want to, and then come back and say, oh yeah, this was easy. Right? It's easy for someone that has obviously done game development for 20 plus years. I have not. I'm a tech support guy. I know how to tell people to restart their machine. But anyways, we are here center origin, that's done. Then we have another public void, and this is a draw call. So again, this sprite actually implements its own draw call, which I absolutely love again. We just pass in a sprite batch, and we'll just call it sprite batch. No, not batch, sprite batch. And what else do you want? Do you want another vector too? Calling it position. Okay. And let me go and copy the documentation for that. Cool, and now we need to go and actually flesh out this function. It's essentially one single line where we say, hey, region.draw. Right, because we've already got a region out of this, and region draw, which is attached to the sprite batch, we go and give it its position, we go and give it its color, the rotation, all these properties that we've defined up top are now coming into play here. So we now have the effects and layer depth. Boom. Let me go and clean that up. How are you doing anyways, Files? Long time no see, so to speak. And can I just say, we love it here. We love our new place. We finally got gas central heating yesterday, which made such a difference as well in our heating. Love it. But yeah, I'm at peace. I am happy, and I'm finally doing what I love doing. Computer stuff. Like, not just gaming. I wanted to do this for fucking years. Now I'm finally doing it. So now, interesting. While we get region method for the texture atlas we created in chapter 7, works well for retrieving regions, creating sprites requires multiple steps. We need to get the region by name, we need to store it in a variable, and then create the new sprite with that region. And then we can just simplify this by adding a sprite creation method to the texture atlas. So when we're saying create sprite, you go and find the region name within that XML document, and you go and make the region out of that and return that as a sprite. Well, that's simple enough. I will only. Now, I am trying very, very hard not to copy code, okay? Because like copy pasting code and just dumping it into your source file, I feel like I won't understand what I've just copy pasted. Me typing out those lines and seeing the code completions happening as we go along helps me get a better understanding of what we're actually doing. The only thing I will quite happily copy is documentation, where I'm just going to say, hey, I have no interest in typing all that out. But I will, of course, yeah, and this is a public, it does return a sprite, it's a text, or create sprite, sorry, jump ahead there, create sprite, and it gets passed in a string of region name. Not this string, honestly, my typing today is terrible. String region name. Okay, when we do that, we basically say texture region. All right, we make a new region. That's what we're doing here. And we'll just say, hey, get region for that region name that we've passed in from the outside, and then we just return a new sprite from that. Right? Yeah, from that region, we return that new sprite has been generated. And now comes the point where we actually need to use this, obviously, right? So there's a few changes we need to do. Right up here we have the sprites instead of regions. So let me slime dodger, go up here. So this is not a texture region, this is a sprite. Oh. Okay. Then you are, where's this? This is in load content, that's what I thought. Okay. We don't do Atlas got region, it's create sprite. Create sprite of slime, and then the same for the bat. Right? And we need to give you a scale as well, which fair enough. And really? I feel I want to shorten that expression a bit. Basically what it wants us to do is to make a new vector2, right, with 0.4f, no, sorry, 4.0 f, so 4 times the scale, comma 4.0 f. I feel like I can shorten this to say vector2.1 times 4.0 f. No? It's not a new in that case, it's vector1 times 4.0 f, like that. That feels like it should have the same result. Because we're taking 1 times 4, which is 4, and that is our scale factor, right? And then we just need to change the draw color a little bit here. Oh yeah, this is becoming so much easier actually. Slime draw is now much shorter. Slime draw becomes, instead of passing all of that in, we literally just tell you this is a sprite batch that you are working with, and that the position is basically vector2 0. So 0 0 at the very top. Vector2.0. And then we do a bat draw also with the sprite batch. And what's going to be your origin? All right, okay, that's. Yeah, I can actually understand why you would do this. So we make a new vector2. And we give it values. One is the slime's width plus 10, just to make a bit of space between it, but stay at 0y. I think that's it. Right. Here's the thing. We should end up with exactly the same output as before, just that we're now doing more efficient things in terms of the loading of the sprites. Shouldn't do it through regions anymore. We're actually retrieving individual sprites that have already been defined through that region. Let's just very simply say make clean and make run. See what happens. And yes, exactly the same result. Right, so we didn't break anything. I'm happy about that. That actually concludes lesson 8, chapter 8. Fantastic. Chapter 8 done. And we're going to say converted texture regions into sprites. That's literally what we've ended up doing. Instead of dealing with texture regions, we're now converting them straight into sprites and loading those in. Fantastic, cool. And yes, please sign. Sync that up to Codeberg. Cool. Let's have a look. Because now I would like to obviously merge that in New pull request. Thanking you. Fantastic. So now what we do is we go and check out main and pull all the changes down from there. Right, slime. Yes, no, all is good. Just running through quick formatting here, fixing any formatting errors that may be. Oh, yes. This holds individual sprites. If I can type individual sprites. Yeah, that's all it does. And shit. We're now on the main branch, but no, this is fine because I can git stash that and we will. Yeah. So let me go here, and what we're going to do is git status, and then it says, okay, there's 2 files modified. What I'm going to say is git stash. Right. We now, if I go git status, there's no changes. What I can then say, git checkout. You can do this in Visual Studio Code as well. It doesn't really matter. Checkout B. Basically make a new branch if it doesn't exist. Chapter 9. And then git stash pop. That brings those changes back to us, and then we can work with that and say, hey, we are now on chapter 9. Added documentation missing from chapter 8. Whoops. So we're now in chapter 9. Nice. Let's go and publish that branch. Sure. And what I would like to just quickly test, because I hadn't actually done that, make docs. Oh, okay. There's something went terribly wrong because yeah, this is on me. I haven't actually made a doxy file, so let's go and quickly do that. This is Slime Dodger API documentation for MonoGame project. Slime Dodger. Product version don't matter. We can give you a logo, which is this. Right, source code directory. That's where it becomes interesting. So up, it's the library that we need to choose first and do scan recursively. Also, if I do export, where is it? Project logo, project item, output directory. No. Come on, where's... I mean, this goes into documentation or docs. Choose that. Documented entities only. Yes. Optimize for Java or C#. Yes. With the navigation panel, yes. Don't need LaTeX. Don't need man pages for that. Just a normal HTML generation. And do this. Full graph with visualization expert. I need to know. Where in the is it input? Yes. So how do I, yes, up. Now we get this, choose, and then we have two directories now being scanned for XML documentation. I think that's all I'm needing for that. So we're going to say next, no, actually just save. Where's workspace, repos, learning, MonoGame, and right in here, the doxy file, buffed. All right, let's see if that works. Okay, 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 make serve docs. Is that gonna work for us? Komme und zeig mir die Nacht. Komme und zeig mir die Nacht. Komme und zeig mir die Nacht. Marie. Localhost 8080 and yes. I mean, this is not necessarily meaningful for a game, but how do I say this? I want to build a good habit of documenting. Like whatever I program, I want to make sure that I'm documenting it in such a way that I can go back to it little years later and understand how it came together. Mm-hmm. Yeah, this is ensuring the singleton. And you see it sort of drilling down from the actual game into the library into the MonoGame game class. I love this. This is so cool. Can look at our classes that we've made. You know, there's our texture region, for example, every class and every property being explained. I love this. Like, this is, to me, is somehow important. I don't know why, but I feel like documentation is half the battle. But yes, thank you. We now work on the chapter 9, which means we are now taking those sprites and we are animating them. Woohoo! And so this is essentially what we're going to look at, right? If we remember from our picture in the actual texture atlas, let me go and grab him quickly. Where is it? Yeah, dodge. No. This directory should not exist anymore. My God. So here's our atlas PNG, right? Let's go and zoom in a little bit, and you can see like there's 2 frames for the slime, and it looks almost the same, but you can see sort of in the middle this part is a bit smaller, and there's 3 animation frames for the bat, literally flapping its wings up and down. Right, so, and that is represented, as you can see here, in these sort of 3 pictures just being played at the right speed, essentially. Which means we need to make an animation class, we need to get the right properties, and so forth. So let's just get into it. And that means we need a new graphics class, animation.cs. And again, we embed this in the same namespace, novice game library.graphics. Again, we make this a file-based namespace. I don't care about scope-based. No. But yes, always feel free to ask any questions you may have. Okay, so public class animation. That's all we're going to need at the moment, just to make animation. So we need 2 properties. We need a public list of type texture regions. And those are frames of the actual animation, right? This needs a getter and setter. this holds animation sprites, animations for animation sprites. I think this is what was going to happen. Animation sprites. So this is basically the texture region that makes up. God, copy. Texture region that make up the frames of this animation. And you need to in the next line. Excuse you. Thank you. Then we have a public time span delay. Again with a getter and a setter. And this is literally just essentially the amount of time we need to wait between each animation frame. Exactly what I thought it would be. Yep. That's exactly what it says in the description as well. So the amount of time to delay between each frame before moving to the next frame for this animation. Now, here's the thing, because depending on the amount of animation frames or how smooth you wanted, you can wait any amount of time, but you still want it to look obviously smooth. So, you know, I'm not entirely sure how you would ensure that, but we will figure that out one after the other too. Yeah, I'm confident somehow. Now we need a constructor, and it won't take in any parameters. However, it will basically say that frames is. Let me go and skip that. Frames is a new list of texture regions, right, with no actual construction parameters. Not that it needs any. Frames, and then we also say that delay. All right, okay. So the delay time span from seconds or from milliseconds. From milliseconds, and you want to make that from 100 milliseconds. And if I actually gave you a delay, then you would probably do this differently, right? So public animation, we can basically say, hey, same idea, but we actually give you a list of texture region, right? Call that frame, or frames even, and then a time span called delay, which now we go and say, hey, frames is frames, and delay is delay. Right? Fairly straightforward, because we're literally just passing those parameters in here, frames and delay, and we'll just make them available to the actual property up here. So that is fairly straightforward. On this literally just creates a new animation. The other one, however, is create a new animation from, you know, with the specified frame and delay S. Create a new animation with the specified frames and delay. Frames is a texture region. Oh, actually, nope, it's not. It's a list of texture region. An ordered collection, okay. And ordered. Oh, yeah. I forgot about this. Lists maintain their ordering. That's why it's an ordered list. Okay. An ordered collection even of the frames. Of the frames for this animation. And then this is time span that we feed in, and the amount of time, or yeah, of time to delay between each frame. Ah, you don't like this. What if I try and escape that? It's not gonna. No, you don't like it at all. Um. I need to go and ask the internet a question. XML escape those. Less than greater than if we just use those. Yeah. I remember actually. Somewhere in the deep depth of our mind, this is a less than and this is a greater than. So and GT. And then that should not cause that error anymore. Yeah. Fine. Okay, this is essentially just how you need to encode this in HTML/XML. Right. What else are we doing? Oh my god, time's running away with me. That's the animation constructors, and now we are actually going to create animations with the texture atlas class. Okay. So what's going to happen first of all is we go into our atlas definition and it gets slightly changed. And when I say slightly changed, it's actually quite a big change, but it does also make sense. So let's paste this in here and let's go on through this, okay? Essentially, we are making a container called regions in which the individual regions are defined, and we're basically looking at the slime 1 and slime 2 frames. It only has 2 frames, and the first frame is at 0, 0. It's 20 and 20 pixels with height and wide. The second one is 20 pixels below that, again 20 by 20 pixels. Then the bat 1, 2, and 3 animations are 1 over from the original slime. Again, all with the same height and width. The second frame is below that. And then the third frame is actually to the very right of that texture atlas. Like 40 pixels over to the right and 0 pixels high. So it stays at the very top. And then we also have a new thing here, new container, where we actually say, okay, animations. Again, this is a sort of container for XML in which we have 1, 2 animations, and each animation has a frame, which we are literally just deriving out of these region names. Okay, and it even has a delay defined here. So this is essentially all we need for that part. And now, where are we working? And we're now working on the texture atlas to make this work with animations. Okay. So we need a new dictionary up here. Private, is it a private dictionary? Yes. A private dictionary of type string and animation. Okay. String / animation. And we'll make a new one, right? We'll just... No, we're not actually. No. Animations _ even because private. And then in the constructor animations is a new dictionary of string to versus animation with no actual construction needed. You need to do this in both constructors. Okay, then we need to add 3 more methods. I want to find the beginning of this function here. There we go. And I want to go underneath here. So there's a public void add animation. No pointer stuff. So what parameters do you take? The animation name and then the actual animation. Okay, string animation name and animation called just animation. Right. Next, we animations dot add, and that takes in a string, which is name, and just animation, right? And yeah, I animation name like so. Yeah, I know about the missing XML documentation. It's fine. Add the given animation to this texture atlas with the specified name. Animation name is literally just a string containing the name of the animation, and the animation itself is actually holding the animation to add. Okay, then we need to now go and get animation and remove animation. So that actually does a return of animation. So get animation with string animation name. And it literally just does a return of animations with the index of animation name plus dictionary. Then we have a public bool remove animation, if I could type. It also just takes in a string animation name, right? Animation name. And then we do a return animations remove. Okay, return animations dot remove. I said dot remove. Dot remove, and it's animation name that we try and remove. And if that is successful, return that. Oh, actually, just return the value itself. Okay. We've done that documentation. Let me just go and copy these quickly. Just again, helping ourselves out to understand this all better in the future. Do some formatting, thank you. Holy fuck. Yeah. So this is in texture atlas, and we need to change the from file. So once we have atlas add region, we go back down here, right? I'm just gonna go and grab a whole bunch of documentation, right? The animation element contains individual. This is what we had looked at already in the XML, so I understand that, I think, well enough to now work with this. So, wow. Mouse, keyboard, thank you. My God. Animation element, root element, animations, capital A, element dot elements, because we want to get all of them named animation. And Can probably even do this guy here just to prevent any issues there. If something, if animation elements is null, okay. Animation elements is not null actually. Then we continue. Otherwise, I'll break out. God, for each something. For each var animation element in animation elements, right? For each of those animation elements in the animation elements collection, we first off grab the name. So string name is equal to animation element attribute. Okay, animation element dot attribute name. Name dot value. Okay, it's just these null conversions. I'm just not going to worry about them so much right now. Float delay is, or delay in milliseconds, I suppose, is float.parse. Jeez. Yeah, we've seen this before. So basically we go and parse animation element dot delay. Oh no, dot attribute. Jeez, no. Dot attribute dot value. Value, and if that doesn't come back properly, we return 0 as a number. And the attribute itself that we are looking for is just called delay. Say, how are we looking? Okay, then we still have more things to do here. Time span delay. Oh, yeah, no, the delay. All right, okay. Delay is time span from milliseconds, passing in those milliseconds, delay in milliseconds. Okay, that sets that up. We then say that we make a list of texture regions. Again, this is going to be an ordered list, and we'll call this frames. And it's animation element dot elements of frame, capital F. Right. No, I think I did that wrong. I think what happened here? Time span delay, list texture regions frames. Oh god, yes, yeah. This was wrong. This is actually a new list of texture regions with no constructor. And then once we've made that list, we can say var frame elements is animation elements element dot frame. Something like that. Right. And then if frame elements is not null, So again, making sure we actually got something back, right? Then for each frame element and frame elements, okay. For each frame var frame element in frame elements. String region name is basically pulling that from frame element attribute by the name of region, right? Yeah. Yeah, region dot value. String region name is frame element attribute of region dot value. Okay, weird way of pulling things out of XML, I'm telling you, but it's fine. We'll make another texture region, which is just called region. Okay, and we say atlas get region. Nope. Get region, and then this is our region name, right? Yeah, atlas get region of region name, perfect. And then, okay, we just add that as a frame. It's just region, right? Okay. You have some formatting issues, sure, not a problem. And then we say after that, we say animation is equal to new animation frames, comma, delay, atlas.add animation, basically name, comma. Oh, always that work, always that pesky real life, huh? Absolutely gotta hate it, but welcome back. Nice to see you. And we now have name's been derived up there. It may or may not be null. I'm actually not curious enough to fix it all. We need to make another class. This is just animation. We now need to make an animation sprite. Sorry, animated sprite derived off of sprite. Okay, so in graphics, we make a new file, animated sprite.cs. Again, namespace novice game library.graphics, and it's a public class again. Animated. And we have a few members. So first we have a private. Oh, oops. Private int. So there's an integer number of current frame. And then we have a private time span elapsed. Make another animation available for us, and then this is it's a constructor, is it not? Public animation that feels like a constructor, but I may be wrong. No, it's a constructor, but it has a return value. That's I think what we're looking at here. And then I say get is essentially the output of animation. Why you no happy? Only assignment call and command can be used as a statement. Public. Oh, right. Get animation and set is animation equals value. No, why? Something feels weird here. Are we, what are we missing? Are we missing maybe? Private animation is an animation. Public animation is an animation. Oh, wait. This is not a function call as such. It's a member. That's why I did wrong then. No, hi, Baro. I haven't stopped yet. No, I usually go 6 hours. I always start at 8 o'clock in the morning, UK time, and go until about 2 o'clock in the afternoon, depending on how much my brain can keep up. But yeah, we're still going. We're now working on animations and animation sprites. So retrieving things from texture atlases, and have the individual frames be added into an animation thing. And we will just keep going until I can't. Animation.frames 0. Why? Okay, so sets the animation for the animated sprite. That's interesting. I think we are actually not properly indented. Oh, yeah, no, you can't exist there. Yeah, that makes more sense, and then this is all just null reference and XML stuff. Okay, let's document. Well, enjoy. This holds an animated sprite. Yeah, derived from the sprite base class. Gets or sets the animation for the animated sprite. And then we have a constructors, two constructors as a matter of fact again. Oh, yes, you need no, not there. Right, C2R. C2R. 2, 1 has no parameters, and this is literally just a construct and animated sprite. Right now, creates a new animated sprite. Whereas this one will take in some parameters, and let's go and get those in there. And okay, we're literally just feeding in an animation. Creates a new animated sprite from all right, with sprite with the specified frames and delay. And then we basically just say here it's animation equals animation, because we're just passing that in from the constructor there. Let's go and code clean it. And then we have an update function. Okay. Public void update. Is it override? No, it's not. We just pass in game time or let me go and grab just the documentation for this. And then we can go and fill out the body of this function, meaning we say elapsed is basically game time elapsed game time, right? We then say if, right, if something, if basically if the elapsed time is greater or equal than the animation delay, animation dot delay, right? You basically move on to the next frame, right? First, you're saying that elapsed is now becoming the same, no, minus equals animation delay. Animation delay, and then current frame plus plus. So this is a bit of a weird notation. This doesn't really look like anything, but it actually means take whatever variable is in front of the plus plus and increase it by 1. Like that's why you're seeing this plus plus. Minus equals is sort of like saying elapsed is elapsed minus animation delay, but you can just simplify that into this one short expression saying minus equals, which then assumes that elapsed is going to be in front of here. It would basically look like, just as an example, it would basically look like this, right? Like internally. So yeah, current frame plus plus, and then what? And then we check if current frame is greater than the animation frames count, because then you don't need to wrap around, because otherwise you would try and get frame 4, which don't exist because it goes back to frame 0. Right, something like that. So if current frame is greater or equal than animation frame count, animation.frames.count, and you're going to say current frame 0, right? Yep. Current frame equals 0, basically resetting that for us, and then we say region is equals to the animations dot frames of the current frame. Just yeah, retrieve that current. As we iterate through the animation frames, you basically check it on which animation frame we are, pull that current frame and add it into the region so we can draw it. And now we need to, in the texture atlas class, we need to go and make a slight change there again, which means we yes, I have yes, I'm due a break and I've completely overstepped. So let me go and take a quick 3 to 5 minute break. Sorry, folks. We are actually on our last hour, but I don't think we'll finish this today. I feel like if once we have some animations going, we're good already. But with that, if you like this sort of content, give me a like, a follow, a subscribe. It's always well appreciated. And yeah, if you have any questions, hit me up on chat or leave a comment down in the doobly-doo. And with that, I shan't be long. And I am back. So, how far off are we actually of getting animations, I wonder? So again, we were sort of now updating the texture atlas because we had made an animated sprite in that atlas, right? We want to obviously simplify all that. Thank you. So let's go, and in texture atlas, we make a new function down here. Let me go and grab the documentation because I can't be bothered typing all that out, not if I don't have to. Which, let's now make a public animated sprite, create animated sprite. You probably take in a parameter name of animation name. That means it's a string, right? Animation name. Animation is a new, get animation right with that name, right? Or animation name, that's called, yeah, animation name. And then we just return that. Animated sprite of animation. Cool. So that basically finishes off the texture atlas class. And now we need to just start using this stuff. So let's jump into the main program. And now these are not sprite, these are animated sprites. Okay, then we here we now go, instead of creating sprite, we're saying atlas.create animated sprite. Right from slime dash animation. And this is also a create animated sprite now from that dash animation. Okay, now we need to, first time we're actually doing something in update. Love it. Here's update logic. So we now say basically slime.update with game time, right? Just pass the delta time in, do the same for the bat. Okay, this may or not run. Shall we try and build it? Make clean, make run. Go. Build it. And I don't see no animations. Okay, what did I bad update? I must have forgot something somewhere. Texture atlas create. Slime animation, bat animation. Did I get the names wrong? Where is my atlas definition? No, that's exactly what they're called. Slime atlas create animated sprite from slime animation. Is there anything else we need to do? I feel like Yeah, create animated sprite of slime animation. Like that basically goes through, it says get the animation, which returns animation name, which is defined up here as a dictionary, which means we have somewhere further down here, where is it? From file. Here's the animations element, root animations, elements of animation. If it's not null, go through. I fucky wucky something. So my OBS screen just went off. Animations. I really have buggered this up somewhere. Let's go through. That's the animation constructor. God, where am I? Right here. Its frames is a new list of texture regions. We then say the delay is timespan from milliseconds 100 usually. Or we create it with the list of texture regions, calling them frames, and we take in the delay as well and pass that in. Okay, so this is fine. Just think. Okay, maybe. I'm not sure, but maybe we need to rebuild the this thing. Right. What I mean is, where is my assets? We're gonna go and grab the MGCB editor and have it rebuilt. Save and cleaning and building it again. I feel like maybe this is now working. Maybe. No. This is now in Texture Atlas. Okay, let's just work through the changes and see if I maybe buggered up something. I probably did, but you know, it's one of those things. So we have. Jeez, there's a lot here. It's a private dictionary of string versus animation called animations. Right. Then we need to. Oh, okay. Did I do that? Yes, animations is a new direct dictionary of string versus animation with no constructor, like when we're not feeding anything in. And the same here, new dictionary of string animation, but not feeding in any values. Okay. And I should now see somewhere here add animation. Yes, public void add animation is takes in a string and an animation. It returns animations dot add. No, it doesn't return. It processes it that way with animation name and the animation passed in from here. Okay, then we have get animation, which is taken in a string, and it returns that private member with that index. Okay, this should just work. Okay, then we have remove animation, which is returning a bool, takes in a string, and returns dot remove of the name. Okay. Okay, I'm going to, because I feel this is like a really horribly long function, I will go and replace, where is it? Here, this entire from file thing, this XML thing is just horrific. I would probably refactor this somehow if I had the choice. And then the animated sprite class, let's look through that quickly. Is derived from sprite. And we need 3 private variables. One is an int for the current frame, the time span for elapsed, and animation for the animation. Okay. Then we say public animation is animation, which is a getter of that private variable. Yeah. And setting is animation equals the value that came in, and region is animation.frames 0. Right. And then animated sprite. I can English. The constructors. This constructor doesn't do anything at all, and the other one takes an animation and just assigns that into the member variable. Okay, then we have update, which, let's go through it. Game time takes the game time. Elapsed. Oh, that wasn't mathing. Basically, what was happening here is that elapsed wasn't getting added to, it was always the same value. Like, it wasn't increasing this. So then if elapsed is greater than equal than animation delay, elapsed minus equals current frame plus plus. Do that same comparison again against the frame count sort of thing, and say yes. I think actually that was it. If I'm being honest, I think that was the mistake there. Like one single symbol. And this is the problem in programming. If you miss a single symbol somewhere, it breaks the entire program quite happily. Even though it was perfectly valid code, that's the best part. But let's try this again. One more time and I think I'll fucking die. Do I suffer? Yes! Yes! Animations! Look at it, it's beautiful! Oh, it's not animating if I do the zoom, but yes, we have a flappy bat and a pulsating slime. I don't know if I should be concerned by that pulsating, but sure. Yes. So that finishes off chapter 9. Nice. I know, woo, right? And I think this is actually really sort of the point here, that I'm learning all this and needing to understand why things work, why they didn't work, what broke. Then, like, this was really obvious because we were doing something with timing without actually changing the elapsed time to increasing values of that elapsed time, you know, as we go through the frames. It's cool to see that, you know, happening in real time, so to speak. Let's make a commit. Neat. Chapter 9 done. And let's we now have animations through animation frame, like animated sprites rather than texture atlas. Done. Commit. Take my password for signing. Sync that up there. And let us now pull that in. Chapter 9, new pull request. Woohoo! Yes, this is all fine. Create that pull request. Create merge commit for those. Thanking you.
Patch.
Right. Making sure we now check in main again. Or check out, I should say. No, not push. Oh god.
No.
There's nothing to push.
No.
It's a pull that I need to do. Right, and there's our new files now. Good. Let's close some stuff here. Feel like I'm getting more tabs than I should have. Don't need you. This can go away for a moment. Okay. Where are we? We still have, I mean, we're looking at 26 lessons all in. We've only made it up to lesson 9 today. Wow. So lesson 10 is handling input. Let's quickly look through how terrible this is. Right, okay, so basically keyboard states are defined by holding a key down and waiting for it to go up again, and that is actually the change of state. That's how you detect whether a button was pushed. You don't just how do you say you don't just detect whether the button was pushed. You actually have to say, hey, was the button pushed, and then released again, and that is one complete button click sort of thing. Mouse buttons, not quite. Although, no, I think it's, yeah, pressed and released, same thing. And the gamepad will pretty much be the same. And gamepads, you have multiple players. You can obviously have, you can, I think, have like 4 controllers connected on the same machine. And then you would say here, player index 1, 2, 3, 4 to actually get the individual controllers as states. Thumbsticks, this is in float or vectors even. Oh wow, that's actually cool. That's actually cool because you sort of get back the entirety of the left stick and right stick in one variable. Cool. But there's a lot of information that's sort of lying behind it. And really, this is just explaining how handling input works. I mean, this is how you would detect gestures on touch panels. Wow. If gesture is gesture type, horizontal drag, then you say if you want to be interested in that drag amount, you then grab from that gesture the delta between those. Wow. All right, okay, so you need to actually loop through that so you're not picking up just a bunch of little tiny gestures, but they actually get read as one gesture belonging to each other. Okay, interesting. And this is how we do input in our game. This isn't actually terrible. What's the time? There's got to be a lot of typing for this, though. I mean, we can reason our way through this code fairly easily. Like, this is literally the main class, right? And we're just saying, okay, here's a position that we're storing somewhere, and we have a speed multiplier. Like, this is the general movement speed of items. We then go and check keyboard and gamepad input, which are 2 individual routines. And one basically says, grab the keyboard state, put it somewhere, and if the key is down for space, then you multiply the speed, so we go a bit faster. If we hit W, we go minus Y, so up. Key down S, so that would be down. We're going plus equals Y, and then right and left, or A and D, same thing. And changes the X position of that. I almost feel like we can copy this. This is literally easily understood. Right? Like, honestly, I'm quite happy just copying some of this into our main app. Patch stop.
Stop.
And so there's our private vector for slime position and our movement speed. Then we're going to say here, check input during update. That makes sense, right? Again, so the update function actually runs before we draw anything. This is when you actually decide on everything that needs to move, everything that needs to be accounted for. This is where you do that. And so we're going to say here, we're not doing this, right? We're doing this nicer. Wait. Oh, you actually want to leave those for now. Okay, I guess. Let me go and put these two routines in here. And I will quite happily, as I say, just copy these two functions because they are easy enough understood. Honestly, this is one of the easiest things to understand. Let me go and drop that here at the bottom. So we've done the keyboard one, right? And the gamepad is essentially exactly the same, just that we are limited to specifically player one's gamepad, so we can't read 2, 3, and 4. We would need to basically you would say gamepad state player 1, gamepad state player 2, and then you can actually iterate through that. You can even do it in a for each loop, I'm sure. But literally just if we're holding A, go faster. If we're going, you even set some vibration here. If we don't hit space anymore, you actually turn that vibration off. Then you're reading the sticks, moving into the right or left position, up, down, all that, and then checking whether D-pads are pressed. This is really super simple, right? Check input. Where is the actual draw? Draw? Sprite batch. Where's my slime draw vector to 0? No. I think this is where I'm actually going to say slime position. I think we actually have input. And I didn't check out code or do the git stuff, but we can easily fix that in a second. And we can move our little slime. Look at it. And then if I hit space, it goes faster. Nice, I love it. We have user input. And then the next part would be making what's called an input buffer. Okay. So let's actually talk about that quickly before I finish off for today, because I think this is the part that we're going to do next time, but we maybe want to talk about this, right? So while checking for input every frame works well for continuous actions like movement, many games benefit from a more sophisticated input handling techniques. One such technique is input buffering, which can significantly improve how responsive controls future players. Input buffering is a technique where the game temporarily stores the player inputs that cannot be immediately processed. Instead of discarding these inputs, they're placed in a queue and processed in order when the game is ready to handle them. So it makes sense that, say you're lining up combos, right? The game might not be reading all of those in one big go. You just read them into a list and let the game just work through that queue of actions and, react to it. It's particularly in games where actions occur at fixed intervals rather than continuous, like turn-based games or grid movement. Precise timing is required. So this is what we're talking about, like with the combos for like Street Fighter or something like that. This is where you definitely would want the input queuing. All right, Files, thank you so much for dropping in, and I shall see you next time, hopefully. But I'm about to close off anyways, so you're not going to miss much. And without input buffering, players must time their inputs perfectly to align with the game's update cycle. With buffering, the game becomes more forgiving and responsive. Storing inputs that arrive between action updates preserve the order of inputs. That's actually really important, and creates a sense that the game is actually listening to the player, which is probably something you would want. And how does this look? So you literally make a queue of vector 2. Input buffer max buffer size is 2. You initialize this new vector. Keyboard state keyboard is keyboard get state. Vector is new direction, vector 0. So you're basically initializing to 0. And then you're saying basically if the key is down, that if it's the up key, if it's being pressed, then we set a new direction. Unit Y, okay. All right, you're basically just negating. This unit Y thing is a bit weird to me, but I think it's to do with vectors actually just retrieving that Y part of the vector. And then only add if a valid direction and does not exceed the buffer size. So new direction is if the new direction is not vector 0 and the input buffer count is less than the max buffer size, then enqueue the new direction. And then in movement update code, so if input buffer count. Right. Right, this is actually not our actual code. This is just a sort of very simple example of this. And this is actually the end of session 10, chapter 10. Let me go and actually now do the Git stuff, because I did sort of bug this up. Right. Git stash. Git checkout branch chapter 10. Oop. Chapter 10. Git stash pop. Bring those changes back. Git commit. And let's make a message for that. Actually, git add a. Forgot that. Git commit all with a message of chapter. Actually, if I don't give a message, I will get a editor where we can do this a little bit nicer and say, hey, chapter 10 done, and say input is now recognized and we can move the slime. And that is now committed. We just push that out to Codeberg. And where's my browser? Where'd I put it? Right here. So if I now go and check here, we should now see a new push to chapter 10. Let's go and just merge this straight into main, because we're done with chapter 10. Fantastic. So then the next thing, before I forget again, we go and check out main. And then say, please pull that all in. Let me go and put you away. And, just to make sure, yeah, here's our check keyboard input thing. Sweet. Yes, let's go and save that one more time. What changed? It's just formatting. I don't care. I don't care. We'll deal with that later. Actually, let's undo that change. Yes. What we're going to do instead is I'm going to branch off right now. Okay. We go and prepare chapter 11. Yeah, this is what I thought. But this is fine. And let's actually close and call it good for today. I mean, thinking about it, we've created a game from scratch in code only. We have got graphics, we have got input, we've made things happen. I'm really, really happy about that. Let me go and pass these onto the raid screen and we shall find someone to raid out to, if I can. Let me say twitch.tv and see who is doing things and all that. Maybe who we can... not that. Let me go and search, or actually let me have a look through who is online in our friends list sort of thing. Maybe we can, surprise someone. I will also take suggestions if anyone has any. But I think I found a target here. Where is he? There he is. Like so. And is the channel going to appear or not? We shall see. Something has happened. I have problems in Chrome. Shit. Yeah, my Chrome's just cacked out. That is unfortunately sometimes how it goes. Let me... Yeah, something's... Like load average 6. Wow. Yeah, I think I'm gonna have to call it actually without rating out. My machine is not happy right now. Well, with that, I would say thank you so much for joining me today. I will be back tomorrow. We will probably continue this adventure. Or maybe I'll do some Factorio. I haven't decided yet. But I do apologize for not rating out. My computer just doesn't like me right now. Yeah, not happening. Gonna have to probably reboot or something, but I shall do that afterwards. Guys, with that, thank you so much. Love yous all. Couldn't do this without yous. Peace out and look out for yourselves and each other. And